I've got Dusty here with me, giving me a crash course on Fusion 360. What is the plan for today?
Oh,
Yeah,
right.
go for it.
So, okay, so I started out as I did before. So we're going to sort of work in reverse. I'm going to try and show how I would structure um, making a large assembly so that when you come back to modify it, it's going to be workable, that things aren't going to break too much down the line. So you might have changes, just dimension changes, or um, yeah, it's just changing dimensions down the line. So as you come back and rework it, so just trying to structure it to keep it tidy and not have yourself get caught up where you have references to parts that break and
Mm-hmm.
things disappear and move around. Because Fusion is fairly, it's not the hardiest of tools.
Right.
Um,
Yeah.
so we'll be working somewhat in reverse. Where we start at the high level stuff and work our way back down to basic sketching and using, extrude and revolve and things like that. Um, so I'll start, as I said yesterday, about the using a master sketch. So I find this helpful when you've got multiple multiple dimensions, or one or two dimensions that are driven off other dimensions. So for the hexapod design, this isn't as big a deal as we don't have many dimensions that are actually driven off other dimensions.
Mm-hmm.
The main one that I can see is the spring leg, where we have the spacing between here and here and how much this actuates and where it contacts onto the switch.
Yep.
So we could do this in a way where we have the part for the leg here and we draw that all out, and then we create the part for the spring after that and we use the leg as a reference for it. But then we're somewhat susceptible to, if we make changes to say an inside face of that leg, if we lose that face, we then have to go back and refix all that sketch, because once you lose a face, Fusion is just useless.
Right.
It just drops out entirely. It will save everything as like green lines, green reference lines of where it once was, but it won't have any actual reference to your original dimensions.
Okay.
Um, so it's handy for that sort of thing. I'll give you a couple of examples where I've used it that it's been helpful. So I have this house assembly here where none of this is actually running off joints. All of this is just sitting in place. So I've fixed a couple of it, but I can move this around. I can
Mm-hmm.
move this around,
Oh, whoa.
which isn't great. I should have used right click and ground, wherever it is, ground, the second one down. Or I can also do um, a rigid constraint that should hold it in place. Um, but
Okay.
unfortunately, with that ground, if you are using ground, you have to actually use it on a body, so it gets a bit messy.
Yeah.
Anyway, instead of driving all of these dimensions, the dimensions of the house and where everything sits by joints, and having to come back and try and find the joint to move it, say, half a meter or something, or move it on the section, and just trying to place things on the section in general, I have a master sketch of it. So this is my um, my section size. This is the house and the garage, and I can edit this, and I have
Oh, wow.
dimensions from the boundary, sizes of the garage, where it sits in relation to the house, and where it is in relation to the section. So if I wanted to move this out half a meter, I can go 3,500. I could shift this in half a meter, go 8,000. I do that. I save it, and with how I've structured this, this is all in separate files. So each of these are a separate file. When I say file, I'm referencing these files on the left.
Okay.
Um, so now that I've saved that sketch, each of these files that are out on the left reference that sketch for where they are placed, where I start the sketch. So I can hit up here, which references links. So you can see it had the orange triangle. So it's going back through and it will grab each of those files, update them, and then pull that latest version through. But it hasn't saved the change yet.
Yeah.
You'll have to give it
Is
a
it
minute
frozen
because
for you?
yeah,
Okay.
it is.
Okay. Good.
This it's because of the big mesh of the section. It
Yeah,
just
I
it just
figured it was
struggles.
loading, but I was just yeah. Okay, so
Yeah.
everything just moved where you did it in the sketch in the actual
Yeah. So
template. That's
everything
cool.
moves. So this is still coming all the way out because I'm driving it by those dimensions.
Right.
So I don't have a gap there that I have to deal with. And yeah, and it's just moved on the section. So everything moves in place, and I can, if I want to make changes, I just pop back to this, and this drives most of my changes.
Mm-hmm.
So I have the same for, say, the window locations. If I want to move a window, I come in here, I can actually do it. I come in here, I can change this to, I don't know, 500 or something, say 1,000.
So what is that? Because like obviously the window doesn't go to the ground, but you just have a rectangle.
Yeah,
Did you
it's
use that rectangle to make the window?
so I
Yeah.
use this rectangle as a reference to where the window is. So I'll show you it. Um,
Huh. Okay.
so where are we? It is house. This is a mess, so don't take this as a um, as a good way of doing
Yeah.
things. This is just a giant cluster that's like 9 versions old. So in here, I'll have to save. Oh, I don't have to save that. Sorry. So in here, I have my walls with jib, and somewhere in here is this window.
Yeah.
So in the sketch here, I've projected in just one of those lines of that rectangle down below,
Okay.
and then I'm using that as a coincidence to the edge of the window here. So that's just setting the width
Huh.
of it.
Yeah.
It's not setting the height, but just the width of it.
That's really
So
cool.
if I did want to change height, I would come back in here, or in my master sketches, I can have a second sketch that, that has a line going across, and that sets my heights for things.
Yeah. That's really cool.
Yeah, so it's one way of doing things. It may not be the best way, but I find it works quite well for Fusion. So I'll get out of there and show you another place where I've used it in a bit more of a constrained way. So this is my 3D scanner design. So I again have a layout master that is dictating the size of the entire thing.
What
And
what is? Oh wow. Okay.
it, yeah. So it's dictating the size because I'm limited to a print bed size. So that's the outer rectangle.
Yeah.
As well as camera angles and things like that. So if I hide this and that and that and that, you can see I've just got a basic layout with these are my cameras and about where they sit. This is an LED. These are lasers. This is one of the PCBs in it. This one's like where my hand grip should sort of be. So it's about the front of the edge. But all of this is fully constrained.
Yeah. Wow.
It's a mess. It's a mess, but it's all the main dimensions. So, for instance, this laser line here is driven by the angle of the cameras. So I'm having it hit a point in here as my
That's cool.
reference, or I think it's a midpoint somewhere here. So as I make the build plate bigger or smaller, say 200, it should have, but everything should scale out with that. If I did it properly, it would, but let's
Yeah.
not talk about that. Sorry, if I do say that one there, 190. I'm scared to move things too much, it
There
will
you go.
break. Yeah, so you can see where you have, just a bunch of stuff that references other stuff, and it's driven by those dimensions. Having a master sketch really helps with just basic blocks of what you're doing.
Mm-hmm.
And then, from there, all of my main bodies are driven off those sketches. So for the outer body, this line here is right on the edge of that print zone. So in that sketch, I would have brought that through. I would have brought this edge through, and just started in that way. And I'll show you this because it's a about the Tibia sketch I've done. But you can see what I'm sort of referencing. So 3mm from the edge of that LED. I'm right on the edge of this coincidence on there.
Yep.
And that's giving me all my dimensions. So if I change that bead size, all of these dimensions would change as they're driven off of it. And I'll show you down the bottom here. This is how you should try and set up each of your sort of feature sets in a part, ignoring that this is all just as one body, because no parts move in this assembly, like it's rigid completely. So I don't need to worry about a heap of joints or anything. Like everything's fixed in place. So I can just have it all in this one body, and I have multiple bodies that are created, because one body in a part, so this, one body can't move in relation to another body, right?
Right.
So if you want two parts to move, you have to have separate parts. But yeah, as I say, because this is completely rigid, I don't have to. So what I was saying before, you can see down the timeline here, I'm starting out with my sketches and extrudes. I'm then doing, like, getting the very basic shape of things, doing mirrors and things like that, and then I'm doing all of my fillets and chamfers and things like that.
Yep.
And I like to, and I don't have any sketches after that point. Once you do your fillets and your chamfers, it's then hard to find dimensions.
Yeah.
So for instance, this top edge here, where I've, it's not a fillet, but where I've rounded that off, if I did a sketch here and I wanted to grab that top dimension now, it's not so accessible. But if I did it before I did the fillet, then I can just grab that line. So that's why I try and structure things where I do all my sketches and all my extrudes, and then do the nice rounding and making it pretty sort of thing.
That makes sense.
Yeah. And you can see down here, I've got these as groups. So this is, once you go to the end of it. Once you create multiple things, you can right click on it and create group. So for this, I've managed to structure it nicely where I have a group where I create the main body. Again, where I'll show the lid as well, where I split it up and create the internal cavity, dealing with all the internal geometry of here.
Mm-hmm.
So if I show all these features, you can see they're all in that one place. They're all centered around that, just designing that one area, right?
Yeah.
And then doing my mirrors and combining and everything, and it just continues down like that. So every group here is doing a separate part. So this is all of the mounting for the laser. This one is all of the mounting for the switch, things like that. So trying to do things, keeping a note on your timeline and not doing things out of order. Or if you are doing things out of order, like if I now want to make a change to the switch, I'll, instead of doing it right at the end here and just creating a new sketch here and going at it, I'll make sure to come right back down the timeline to where I actually need that and make the change there. So it's just trying to keep it in a group, because you can scrub things back and forth through the timeline, but it's not very tidy to do, and it is limited. So if you create a sketch, like if I create a sketch on there, I can't move that sketch past that point. Or if I have references of something from there, I can't move that sketch past where I pull those references in, if that makes sense.
Yeah, no, it does. That makes sense.
So yeah, as I said, this is a lot of high level stuff just to get started.
So this is all for a not, like, one part that's not moving. You would this is a nice workflow. Yeah, that makes sense.
Yeah. So
one question, one thing I was having an issue with. So let's say So if I don't move the little playhead thing at the bottom into the group, and then I do
Yeah.
stuff, I you can't put it into the group after the fact, right?
As I say, you can sort of scrub it through the timeline. So like I could grab
Like
this and try and
that's
move it
already in the
back and
group
forth.
though. I was having trouble putting things
Um,
in a group.
So the workaround with that is if you, you'll see on one of them, if you stop using a group and like you're trying to add something to it. So I want to add something at the end of this group, right?
Yes.
Here, I couldn't. So I've gone back. I'll do it on a new one. So where I haven't done it. So in this one, I want to keep adding to this group. If I sketch now, it won't. It will create it between those two groups.
Right.
So I'm going to go back here, just construct a point at vertex,
That's really
chuck
smart.
it there,
Yeah, and then
go
to the
OK,
left of that. Yeah.
and then I'm just going to scrub it to the end of the group. So, and then now I'm working in that group.
That's I feel like you shouldn't have to do that, but it does make sense. All right. That's good.
No. I had to look that up like the other day to figure out because it's just a nasty workaround, but you know, a point's not really going to break.
Right.
Yeah. Okay, so that's the general about laying it out. So we'll actually jump into bloody trying to make a hexapod now, eh?
So how would you approach this? Because you just showed a single part, so that would be analogous to like maybe just making the tibia, which doesn't actually move. Well, that's a bad example because the spring moves, but you get my point. But I want to make 4 parts that all move, like that are all jointed, right? Tibia, coxa, femur, and the body. So yeah, how would you do that?
I think for this, because you have so many references that I showed you yesterday, the parameters, the what's it called? Oh, yeah. Where is it? What's it called? You know the one.
I swear, no, user parameters, right? You can search it.
Yeah. Okay. Oh, it'll just be because I'm not in a sketch or something.
Oh,
maybe.
Yeah.
It'll be because of this. Anyway, because you've got parameters with heat sinks and things like that, things that are going to be shared over this part and this part and this part sort of thing. Instead of breaking it down into multiple files on the left, we're just going to keep it all as one file for the main drawing. So we're going to recreate all of this as one file with your main parts, but no duplicates of parts, right? So we're not going to actually do the assembly because assemblies get messy. Once you start moving around and try and create sketches after things have moved, it gets really messy, things break. So we're going to avoid doing that by creating one file where we essentially replicate this part, and then a second file where we pull all of those parts in, hide the ones for each part, and we'll create all our joints and put the full assembly together, and that can be fully actuating and moving around, and that'll be our messy our messy assembly, and so we'll have one messy assembly and one tidy drawing area. And then so when you make changes, you just come back into the drawing, make your changes, save it, and as I did before, update it up here, and you're good to go.
Okay.
So we'll start with that. So where were we? Parameters. So for this, you had your heat sinks, right? So
the heated insert hole size,
So say heatsink diameter of 6 and a heatsink depth
5.
We'll call that 5. So that's your user parameters, and those are going to be usable across everything that we create in this part. So that's why we're going to keep it all as one, is because you've got, as I say, because you've got a lot of parts that are going to reference those user parameters. Otherwise, if you kept it all separate, you'd have to go to each file, change those parameters, and it's just not so. It doesn't work how you want it to. You know, you want to change it in one place and be done. Okay, I need a drink. I'm talking too much.
Yeah, of course. I will drink too. Yeah, so obviously, I mean, you're not going to make the whole thing right now. I mean, definitely do not do that. But so what? maybe like
I'm
how would you go about like planning this whole thing out, like because I feel like everything is built off of that motor mount piece. I think that would because
which
that's
one if you
so yeah I can actually move your mouse I think.
Mhm.
Oh, hold on, I forgot. Oh, you have different camera controls, don't you?
Oh,
This
yeah.
that's okay. That's
I'm
okay.
working on SolidWorks camera controls.
No, yeah, no worries. This piece, right? It's
Okay.
duplicated 3 times, one for each servo, and like the basically the whole leg depends on the size of that. And I would let me remove my mouse. I would like to be able to change that piece. Let's say I
Mhm.
want to make it wider for some reason. Everything should like
So
update with
so
it.
wider as in more allowance for the servo,
Nope,
or
nope, nope,
wider
nope.
as in
Yeah, that way. Yeah, yeah, yeah.
width-wise?
Well,
Okay.
I guess
Yeah, yeah,
both, honestly, but
yeah. Okay. Well, we'll do both. Are you using the same size servos throughout?
yes.
Okay. So if you wanted, you could create user parameters for your uh, motor dimensions, and
That'd be cool.
that way, if you do change them, you can come back and just change it in here. I won't at this
Yeah,
time,
no,
but
yeah, that's fine.
it's not going to be all that much of a hassle for you to change it how I'll sort of lay it out, or how I'll hopefully lay it out. I haven't practiced this, so this will probably get messy.
It's all good.
Um, so we'll add a new component. This is going to be master sketches. And in this, so we're going to start on top. I'm going to start with the body because
Yeah.
this is the fixed point. Everything like this leg dimension, or this dimension here, this dimension between these 2 points, and between here and the end of the leg is all driven from this dimension on the side
Mm-hmm.
here. So I will start with just a circle for the center location of the servo horns, right? So
Sure.
this is your pivot point. So we'll call it 5. I'm going to, I want it over here because you've got one in the middle there. Horizontal, vertical, dimension to whatever we want. We'll call it 120. And I can do X to make that a construction line. So just to add a tidbit of some of the tools you've got available, if you were doing a hexapod that's evenly spaced legs all around, you can now use a circular pattern
Right.
to grab that circle, center point, and 6. And then you'd have your 6 pivot points for the leg. So now if I move this out 130, everything moves with it, right?
That's really cool.
As we're not doing that, you're having your other 2 legs sort of, well, they're out more, aren't they?
A little
So
bit. Yeah.
we'll do, yep.
Very arbitrary. So if we can, well, let's see what you do.
So
Obviously, I'm gonna be remaking anything you do here. So, but
yeah. I'm not going to give you any of this, and it's just going to be basic as we go through.
I don't want any of
You're
it.
not
Yeah.
gonna you're not going to want to use it though.
Yeah, yeah, yeah.
So I'm using equals. Once I have one dimension of something, I'm not going to add that dimension again. I don't want to dimension everything individually.
Right.
I use these constraints to keep me going. And we've got
The real one's 55 degrees. 50's fine though. Yeah.
5. I like this. I like that you know it off the top of your
I
head.
do. I had to know it for the IK.
Nice. So now we've got that point there. So instead of creating another line here and dimensioning it to 55, which is an option, but then doing the same thing over and over, we'll use mirror instead.
Mm-hmm.
So I'll just grab that. That's why I've created this line here. So actually I want both things. Mirror line there, and that's 2 of them. And mirror again. Crap, I grabbed the points. Sorry. Sorry, if we do mirror and actually grab the circle.
Right.
And so we've now got half of it, and we can go mirror again and grab
the top 2, yeah.
Outside circles, and we've now got our 4 points. And the only thing leaving this sketch not constrained is this line, so we'll just chuck it to, we won't even give it a dimension, we'll just do it equals with something. Just for just for the sake of having it show that lock state once we're done, so we know it's fully constrained. So with that, I would now normally do like the just undo it and actually do it.
Did you need that vertical line, or isn't there like can't you like reference the origin or axis or something, or does that not exist for a sketch?
I actually don't know. You probably could. I guess you can mirror on that plane, but then you're having to go to origin out of the sketch.
Okay, so it's not there unless you like click on it and okay, yeah, fair enough.
Yeah, like I'd use that if I'm mirroring a body or a feature, but because I'm in Sketch, I'll just keep
just
it
draw
all
the
within
line.
the sketch.
Sure. Yeah. Okay.
Yeah. So in this, I would want to do where are we? So we'll do some 3-point rectangles. So we've got our set pivot point. I would want to do the general servo size and then just a outside body dimensions. So I'll try and just whip through this with some arbitrary servo sizes. We'll call it X, and I'm going to have to do the same on that. Equals, and I want these to be, I'll do that after, line between there and there. You can see I'm hitting midpoint there, just that little triangle that shows up. And I can do this one collinear, and it's still on an angle, so I can do this one as perpendicular to square it all up, and just using those same dimensions as before, and X for any construction lines. So that's our servos, and then the general body layout will go, I'll have to do a straight line if I want to do a curve that's tangent to it, because we're going to be mirroring across this line.
Yes.
We'll go but. Okay, and I'll just make this arbitrary numbers just to get us going. So again, just using collinear and everything like that.
Yeah.
Keeping things equal, so I want all three of these to be equal. We'll call it 5 mil, and we'll stick these out, say 2 mil. I want those to all be equal.
So like that 55 degrees that you the angle of the whole thing, if you change that, after you're done, the whole like everything will fix itself, right? Like
so all of this will
really
move
cool.
with it. So
that's insanely nice. If I want to like experiment with different angles to see like what would make the most sense, that's really cool.
Yeah, so you can see like doing that's fix this. That is tangent there. You can see I've got tangent thing, so I need that there as well. I have to do this line here because I want it to be tangent to it.
Yep.
And we'll call that 85, sure. Also, if we didn't want to do that, we could have this be the same as this, and that'll give us the same thing. So I still have a couple of movie lines, so I'll just make those equal to that for no reason, and we're back to a fully constrained sketch. So now if I want to do 40 degrees, not 440, it'll all just move with it.
Oh my goodness.
And this will follow in your full assembly as well. So
really quick, can you make this curve at the same like point as this? You know what I mean? Like, how do I describe that? You can see my mouse, right? Can both of them end at the same like point?
You want both of these curves to be equal along here?
Yeah.
Like,
Yes. Yes.
okay, okay.
How
So
would you
did I
go
make that
about
equal?
that?
I did, didn't I? Parallel equal. So I can just drag this down. To do them parallel. Oh, I can make them equal.
Oh, you just make it. Yeah, that makes sense. Okay.
Yeah, yeah. So I can make it equal if it was, say, up off a bit or something. I'll just use a construction line and use constraints
Yep.
to
Yep.
drive it differently.
Make them perpendicular.
So yeah, that's our basic quarter done, right?
That's great. Yeah.
And then we'll do as we did before, just mirroring everything. That's the wrong way around. So I can double click to select all of that line.
Can you just highlight the whole thing?
Yeah, yeah, just to.
No,
Yeah.
just like with one box. I don't know. Like, can you?
It will sort of do. It'll do most of the round, or like if you've got a separate box, it would do the full box sort of thing.
Mm-hmm.
It's just a quick select. It's, I don't know, it's something.
Yeah, fair enough.
This one, that's that way, and again for the other side. So, wow, it's too many clicks.
Nice.
Okay, so that's our basis, right? You could now add in your cutout in the center if you wanted to, but I think I'll just ignore that. That's, oh, I didn't get the circles. Damn it.
Oh yeah, there's no design history for sketches.
No.
That should be good.
There we go. Okay, so we've got all our circles. I missed one line, but whatever. I'll just fix it because bloody I have to.
You missed. Yeah, bottom left.
Oh, one line there. God damn.
Two, kind of two.
That's the inside one, isn't it?
Perfect. All right, so
there we go.
This is awesome. Let's say I wanted to make it not as wide, more narrow, like squish the whole thing. How is it too late, or you can just change that dimension, right? Or
yeah. So say 100, and we move that in. Would then shimmy with this angle and this distance
you
here.
just
So
bump
we
that
can
into. That's okay. That's
do
really
120 and move it in.
That's really powerful.
Yeah. So this is how you work. So this is why you work in a timeline. So you have your top level design that drives a lot of the overall look of it, the overall dimensions, the main things. And yeah, I find this a good way just to come back to, because otherwise you're hunting through your timeline trying to figure out where you made that dimension, where you made that change, and it can just save a bunch of hunting.
Right.
Okay, so that is the first sketch. So we'll call that base. I'll create another sketch for the leg. What's this first part called? This part here?
The Coxa.
Coxa?
Yep.
Taxa?
Coxa.
Coxa?
Yep.
Okay.
That is correct.
So that is driven in the other dimension, isn't it? How do we do this? Because we've got two dimensions to deal with now, because we're going from this servo horn to this servo horn.
Correct.
Right?
Yes.
So we want a second dimension for the body first. Okay. So we want to draw that servo height on the body to begin with. I'm not going to do it on these other ones, just on keeping to this XY plane, or keeping to this plane, right?
Mm-hmm.
Because once you go off plane and you can't use horizontal vertical, things become a horrible time, which I'll explain as well as we get down to this. I'll draw this in horizontal vertical and keep the off vertical. Anyway, we'll get there. This is going to take way more than half an hour, isn't it?
I mean, you don't have to make the whole thing, but...
No. I'm going to draw it like basic as. Like,
Yeah, yeah, but
that's
hey,
not going to evolve much for
we
this.
got all night. Well, for you it's not night, but you know.
Yeah, cool. Okay, so I'll create another sketch that's at a right angle to it. Project in this circle, which is my center, and I can project in. I'll do that first because otherwise it's project that in. And draw the general box and the horn that is the servo, right?
Yep.
So I'll just go coincidence to these.
Now, why wouldn't so I have a model of the actual servo. Is this so I can change the servo size in the future? Something like, you know what I mean?
Yes, so as I was showing with you with the switch yesterday, I don't want to drive it directly off a model. I just want
Right.
to drive it the basic dimensions of it. So if you change servo size, you know how I said we could put them into the
Mm-hmm.
parameters. Because we're not doing that, if you want to change servo size, you're going to have to come into this body and into the sketch and everywhere that we draw these two boxes
Right.
and change the size and change the size and clearances if you want to do clearances in
So
here or
so
in the body.
those boxes of the flat sketch of the original one,
Yeah,
we could have or should have, I don't know, whatever, used parameters to set those just in case I wanted to use bigger servos or smaller servos or different size servos. And in addition to this box as well, it would be we'd use parameters
yes,
that we
yeah.
can just change later.
Would
Okay, that makes sense. But yeah,
yeah,
okay.
we probably should have. I tend to not use as many parameters as I maybe should.
It depends on the
But
project, right? Like this one, there's tons
yeah,
of repeated things.
yeah. So in this, they are repeated a lot, so it is worth doing. As heat sinks are repeated a lot, so it's worth doing. So in that scanner design, screws were repeated a lot, so I had dimensions for all of the screws. Yeah. So anything that's repeated a lot, it's worth doing. So we'll call this 35. Looks good enough. And 15. And I want this to be right into the middle there. So I'll do that and vertical, and we'll say that it sticks up 5 mil. I actually want that to match, so I can do it coincidence. And that's that servo in place, and you also have your bearing underneath, don't you?
Yep.
So we want this to
Well,
align.
this would have the axle. The bearing would be attached to. Well, I don't know what. Yeah, it's an axle and the bearing. So yeah, just keep going.
Yeah.
You're fine.
Yeah, it'll be living underneath, so we'll do it this way, and we can figure out if it's wrong later.
Well, it doesn't matter what it's attached to. It's there either way. Yeah.
Yeah. Call it a 5 by 12. Bit of a big bearing, but we'll go for it. All right, so I now have 2 dimensions of things.
Mm-hmm.
So I can, so that would be base top, base front, back. But now I've got that, I can do that second part. Sorry,
No, you're fine.
this one. Okay, so we're now coming out and just drawing the same thing. So as we did the rectangle
the
for
bearings
that servo
on the
earlier,
top and the servo horns on the bottom. But you know what? Doesn't even matter. Yeah, just keep going.
how do you mean?
Does not matter. Literally does not matter. Don't worry about it.
Okay, so yeah, I should have done parameters for the servo. So I'm gonna do.
It's not too late. Yeah, I mean, because you're gonna.
Really not too late.
It's all good.
What did I call it? 20, 50, 10, and 35 high, right?
Sorry, that'll annoy me. Servos with an E.
Oh yeah, that's
okay.
20. height. Well, I think it was 35, right? We'll go with 35.
I think so.
Okay.
Doesn't really matter.
Thank you to everyone telling me I spelled it wrong. Okay, so to use these parameters, we just start typing the name. So servo.
That is so nice.
Width,
Holy
height,
crap.
depth. Servo depth.
Oh yeah, I mean you could just do it in the original. Yeah, it's that, and that'll change all 6 of them, right? Or does the top right one also need the parameters?
Not that. One moment.
Yeah,
we've done it as equal, so it's
yep.
it's changing
I
as
forgot
well.
about that.
Servo horn offset. So yeah, that's changed as well along with it. So yeah, it'll move as we
they're all equal.
change
That makes
parameters.
sense. Yeah, that's
Cool. Do this one as well. Servo height. Okay. Okay, cool. So now we can continue on with this. So I want my servo depth. Width. I probably should have done the size of that horn as well, but we'll ignore that for now. Was this at the top or the bottom? Bottom. Just call it 5 mil all the way along.
Was what at the top or bottom?
The horn.
So in your first drawing it's at the top, but in the real one it's at the bottom. So
oh, I see. That's what you mean.
That's the axle.
Okay.
Yeah.
Oh, okay. Well, you can deal with that later.
Yeah, don't worry. Just look, you're making your own hexapod right now. Do whatever.
Yeah.
Do whatever you want, honestly.
Vertical. Okay, so essentially we're starting again, but this is, we're just recreating this part now.
Wait, what do you mean?
So like we're starting as this axis of the servo. We're drawing this axis of the servo like top down.
Top down, yeah. Oh, you hovered that one, and I was like, we're not even looking at that one. But yeah, I know what you mean.
Yeah. So again, we'll do this, and then we'll do a front version of it and get it into 3D.
Sure.
So I can now drive my distances between the two. So we'll call it.
Oh my god, this is the servo for the femur. Yeah. Oh my god. I was like, why are you drawing it over there? No, this is the femur's servo. Yeah. Okay. I'm following.
And
oh my goodness.
We want this in the center, don't we? So I'll project in both of these, hide these other sketches, and do a line. I'll do a line in front just so we can actually see it. Just to try and get this right in the middle of the drive. It's not going to matter, like you're going to have to, do this properly. But that's just trying to align the servo in the middle. I don't know. You do what you want when you're doing it. So that is, what was it called? Femur.
Yep, this is the femur servo. Yep.
But what part was this? This was the inner part. Coccyx?
You're working on the coxa, but you just drew the femur's servo.
Yeah, but we're still on the... I actually need to do model sketch anyway. Okay, I can't spell.
With COXA is probably... Well, you know what? Yeah, it's COXA. Just so we're all using the same words.
Okay, cool. And I should probably do... Now I've got that in, I should also be doing the body around it. So,
yes.
Okay. I'll just do that as cut linear with it. Again, you can do all this properly. I'm just going to mesh it. What?
Yeah, so it's like a backwards C basically, and I mean. That's the basic idea, exactly.
5, 10. 5, that's getting a bit thin there, so we'll do it to that one instead. So this is where you can, drive different dimensions of different places. just to maintain that width. So I'll say 3 mil off that. I want these two to be in line. I want this one to be along with the top of the bearing location. And that can be the same. So you can reference other dimensions as well. So if I want this to be the same as this, I can just click this dimension and hit enter. And that's now, if I change this,
What the
it will
hell?
change both
Wait,
sides.
so can you do that? What did you just do? Hold on. You were editing the bottom dimension and you clicked the top one?
Yes. So I'm creating that.
Yeah.
I click the top one and it
Huh.
calls it D31.
No kidding. That's
and
cool.
hit enter. So I try and just keep that within the sketch.
Yeah.
But it's a handy thing instead of doing like a construction line across and making them equal.
Right.
You can just
do that. Wow.
do 2 dimensions and do that way. A little bit dirty, but not horrible. And I'll do the same thing on this side just for the sake of it. All right. So that's that. I think we want a top-down view. Not sure I even want to bother with. No, yeah. Sort of want to go on to the next leg. Really should have prepped this. Sorry,
No, you're
give me a
fine.
moment.
So there is one part. I'm not sure if this will like be even more difficult. I'm gonna here. Can reference? Yeah. So how do I orbit? There we go. This part is actually on the bottom, but we're gonna because you drew it upside down, but that's fine. So this part kind of attaches to the frame, and it's what holds the axle for the bearing.
Yeah.
And that like right now the bearings there like there's just the servo, right?
Yeah.
Does that matter? Like
no, so we're just driving the overall placement at the moment. Like
okay.
Say we're doing this part, that way up.
There you go. Okay.
And we're going to draw it like that separately later. So we're currently just doing the main dimensions for it. Because all of these body parts are rigidly fixed together, we'll do them all in one part. Once we complete this, we'll create a new part and do all of the body in one part because all of those parts are never going to move against each other.
Yes.
So they can all just be one thing with multiple bodies, as we never need movement. And the same with this, where it's 3 parts, but we're going to do it in the one part with multiple bodies. Yeah. And the rest of it.
All right, I just realized I think I know where. So literally, this line just needs to get bumped down to make space for it. I think, yeah. So, but you can just do that whenever. All right, continue. Yeah. I'm
cool.
I understand.
Yeah, you can. This is getting the overall. You can dive into the details when you actually.
Yeah, you don't even have. Yeah. Okay.
Yeah. Cool. Chat's happy enough. Cool. If you guys have any questions, just chuck them in chat and I'll let you sort of pass them on or something. Okay, sorry, I need a drink. Too much talking.
No, dude, you're fine.
Cool. So we're just going to do the same, creating 3D sketch. I think, yeah. Okay, so another sketch on this top plane with the servo size.
So this is also the Coxa just from the top.
Yeah. So also the Coxa from the top. And we'll just, we'll just run with it. So we're going to do the same thing. We're essentially repeating what we did with the body, but working down the leg, where we do one dimension of the servo, the second dimension of the servo.
So you would draw like just like the whole thing in a sketch first, like top down and side view. You'd get all the sketches done before extruding even a single time.
Yes. So this is, as I say, just doing the overall dimensions of it. So I'm not doing anything detailed here. I'm not doing all of the servo mounting locations, like the holes or anything for it. I'm not doing any details here. I'm keeping it as basic as I can, and just getting those 2 axes that I need to then do my extrudes later on and create the actual bodies from it. but we'll just try and crank it out and
Yeah. Hey.
get
Yeah.
down the line. Yeah, get there.
Sounds good.
What was this? Servo height, depth,
Or width. I don't even.
height. God, I don't.
Oh, height. Yeah, maybe it's height.
It is height. It is indeed height. So we can. We need to project that in. So I'll just do this one line instead. You know, not redoing dimensions where I don't need to.
Yep,
I'll just use coincidence on them. I'm having to hide that sketch because when I was trying to select that, it was selecting this line. I don't want to select that line.
Mm-hmm.
I'll just hide it and do that and do that. So, what was it?
Well, so right now you're setting like where the servo is in that hole, right?
Yeah. So I
guess it doesn't.
From a top down, I'm getting this outside dimension, right?
Exactly.
So
the
right
servo,
around the outside.
The servo is not there for anyone wondering. It's invisible in this reference, by the way.
Yeah. So I'm doing it in reverse, but I'm setting where that servo sits in that location and where that bearing sits. So, you know, those are the two important parameters that are going to drive all of this outside size. And then I'll try and draw the.
Oh, hold on, dude! Shouldn't you use the servo height parameter thing? Oh, you did. Oh, it's right. Oh, man. Okay, I thought that only went to the middle, but I'm blind. Okay, that makes sense.
So I've just got the offset there. I need to think about what I'm doing though. Hi. Okay, so I want the horn on this because I'm coming out this way. Right.
Yes.
Okay. Cool.
Yes.
So I want the horn and the bearing. I'm drawing everything in reverse to what you're actually doing, but you will figure that out.
Oh, hey, this is your own hex. This is fine. Don't worry about it.
Okay, and we'll call it 2, and what do I call it? 5 by 12, I think it was. Again, you should be using parameters for it.
Yep. Anything repeated, that makes sense.
A little bit disgusting here. 5, and I can sort of grab both of these lines. Actually, I can drag it off.
Oh.
Grab both of these lines and hit midpoint and put it back in the middle.
That's cool.
Selecting two overlapping lines is a real pest, but
dude, I didn't realize the triangle was midpoint until like an hour ago. Like, like it does. Okay, anyway, it's a good tool to know.
Okay, so we've got that. We've got the overall size. So we've got one dimension of this. I want to do the top-down dimension, I guess, and you had it captive one side and open the other. That makes sense. Okay. So I've got my bearing side there. So I'm in reverse to you, but we'll do that. Sorry.
So you're right now that's the C, the backwards C. I don't know what you want to call it. The Coxa, I guess. You're drawing the other dimension of it, right?
Yeah. So I'm drawing this axis of it, this top down.
Whole,
so in the last sketch, I've drawn this axis, the backwards C.
Exactly.
And then in this axis, I'm drawing the sort of.
It's like 4 separate parts, but that doesn't even matter. You're just getting the.
No, we're just getting the overall size of it.
Okay.
Even this may be a bit too much detail. I'm not sure yet, but we'll figure this out. Like you may be able to just get away with placing the servos, and calling it a day, and just place the servos down the line and reference your endpoints.
Okay.
I don't know yet if drawing this outside size of everything is going to be too much, but we'll figure that out.
I guess we'll find out, yeah.
Yeah. Okay. Oh, I see. That's in there. Right, that's your bearing side. That's
it's definitely thinner than the actual servo.
Yeah. Right, we'll just ignore it and do it to the servo size to make it a little bit disgusting. That over so we can see what we're doing. And and I'll project in just these vertical sketches that I've done. So yeah, I have a feeling this is going to be a bit overdone for it, but we'll deal with it later. Learning as we go.
Yep.
So that looks a bit confusing, but if you imagine,
No, that makes sense. Yeah, you got the top of it and the side of it. Yeah.
Yeah. Okay, so we're.
Oh, and that's a separate sketch from the base. Yeah, that makes sense because it moves individually. Okay, I guess could it be the same sketch? Could you just do one top-down sketch and one front sketch? You probably don't want to
combine the base and like the base top, the Coxa top.
Well.
I mean, yes, but I'm sort of working. Again, I'm working in a timeline, so the location of these Coxa dimensions where this is sitting is driven off of the sketch.
Okay. Yep.
Because as I move this in and out, now I can go back here and make this 90, and it's still going to follow it.
That makes sense. Yep.
Okay. Yeah. So you could do it in the one sketch, but then that sketch is going to get very complex. So not trying to overcomplicate and do everything in one sketch. Like you don't need to. You can break it up into parts and keep it easier on yourself.
The order is correct. Yeah. Okay.
Yeah. All right. So we're 2 of 4 parts in.
We're doing great.
We're doing great.
You're doing great. I'm enjoying. This is really helpful.
I might do this a bit. Oh no, that'll be easy enough. It's 2 the same. Okay, we'll do it. No, just do it properly. Okay. That is the wrong dimension. And I'm not in the right place, so I started creating a sketch in the wrong place on the timeline. That's not good. And I also did it in the wrong axis, so yep. If you create a sketch in the wrong place on the timeline, you're pretty much just screwed. You need to go back and fix it.
Also, which one is screwed? Oh no.
Like once you. What is that?
Oh, is that because you shifted everything in? Maybe it didn't like that.
I don't know. I think I just had a misclick line. I could see up here though it wasn't constrained, so that's why I went back into it. Okay. Anyway, we will continue.
I mean, honestly, the femur is the easiest part of the entire thing. So.
Yeah, we might.
It's just 3 rectangles.
All right, so we'll do 1 circle, 2 circle, and a jolly slot between the 2.
Yep.
So center to center slot.
So slot is just it's an oval. Well, it's not an oval, but it's a slot. Yeah. Okay. That's a nice shape to know.
Yeah. It's a bit of a handy tool. So if you're doing slots for screws or anything, if you're just designing in some tolerance like that. What do I want this to be? This would be the size of your.
It's either the bearing or the horn. I don't remember. That looks like the horn. Yeah.
I think I actually deleted and just project in this top because this is going to be my side here. We'll ignore the problem. So I've got that. I'll make that say 16 will do. Sure thing. I want that to be coincidence there. I've got it as horizontal. These can be equal. And that can be 100 sounds like a number. We'll go with it.
So that 100 number, after the whole thing is made, I can change that and, well, not even the whole thing, just the femur. It'll push everything in, everything will follow. That's super cool.
Yep. So this is the point of it. I'll do one on top as well, just for consistency's sake. Wrap, and this needs to follow you had it sort of like this.
Yep.
And the bit middle, I'll do some arcs in the middle just to make it fancy, so we can do a 3-point arc. And I'll do that. Again, just trying to use tools as we go, just
yeah, please.
instead of directly explaining everything and what it does, I'll just do, and you guys can do yourself and learn. So I need to go all the way to the end of this, don't I? So if I project this in, how will it look? Oh, it does that. That's okay, cool. So just because it's an arc, I don't know if it will move the whole thing in or not. If it didn't, I could just do a sketch that continues along this line and is coincidence on there. You'll hit that sometimes. I don't know if that made sense, to be fair.
No, I know what you mean.
Cool. Same thing. Linky dink.
Yep.
And now we can set our dimensions for both sides. That needs to run up. That be.
That's great. Yeah.
I want this to be the same each side. So because I'll do it so it's clear. So instead of, I could grab this point and say it's horizontal, vertical, and that will constrain it to the same width, right?
Okay.
But it's not clear what's actually constraining that now. Like finding, you come back 20 days later and try and figure out where this was. If you say want to shift it over, you don't want it in line with the leg anymore.
Well, I mean, actually, I would the top horizontal cross or this part will need to be bumped up to make room for the axle holder thing. You know what I mean?
Okay.
So we will have to move it eventually.
Okay. In this I won't, but I'll just show this just
hypothetically. Yeah. If we were actually doing this.
Yeah. When you come back and do this, you'll hopefully do it properly.
Hopefully.
But yeah, like I'm just, instead of just having constraints that go to random things, I try and do some construction lines and stuff, just so it's really clear what we're coming to, just to save yourself. And I want these to be equal, so I can do a line. I want it right in the middle, so I'll do a line all the way across, and I can do midpoint. And to do these as construction, and set a size. 60 sounds good enough. So now this is bang in the middle as well.
So that line is from the midpoints of both of the circles, but they're not circles. They're the midpoint of the arc or whatever. Yeah.
Yeah. Yeah, and then just a line all the way across, just so I have the midpoint of this feature. So I tend to use that quite often, instead of using a, if you.
What is that? Wait, what is that?
This is a center rectangle.
Interesting. Okay.
So center rectangle or 2-point rectangle are your like common ones. But if you do a 2-point and you need a center line, you just bump across it, and now you've got a midpoint.
Yeah.
All right, so that's that. It doesn't work because we are interfacing into the servo horn here, so I don't really want to be doing that. So I don't actually want it in line, do I? Because I'm going to redo that down there. Okay, I'll get rid of that and not make it in line. I'll drag this out. We'll call it 3 mils from there. You can have your horn on top of it. Cool. Okay, so that's that bit. Looks a bit funky, but yep. Yeah, it just looks funky because it's not, this middle isn't in line with the middle.
Yeah, but it's the top-down view and the side view. Yeah, that makes sense.
Yeah.
I guess it's just weird because you can see both at the same time, but it's all good. Oh, femur, sorry, yeah.
Spelling?
Femur, as far as I'm aware.
This femur side.
Yeah.
For anyone trying to change names, I'm just long clicking on these.
Oh.
So long click and release to change name instead of having to do, my right click's broken, but instead of having to right click rename. Cool, so we've got that, and we want another one for the end. So, gain on the side, I think. Yeah, we'll start out here anyway. Okay, so we've got to think about this springy mechanism here. Now, this is going to be a pest to draw, right? But it's only a pest because it's currently on an angle. So you've got a lot of lines that are, rotate around so you can actually see through it. A lot of lines that are parallel to each other. If you tried to draw it like this, you're having to draw everything parallel to each other and off axis. I don't want to do that, so instead I'm going to set it up so that when we come back to making this stays vertical and this arm is going to be drawn in this direction, because we don't have too many things here that are going to be a pest to draw off axis.
Yeah.
Out of square. I don't know what you want to call it. So I'm going to start with the spring and your, how do you have it? Pointy, outy? Yeah, just a nub coming out.
I don't know. Maybe you want to draw this part. This can be like the actually detailed part. I don't know. I'd be interested in how you'd actually make this. So if that shaft actually connects at the top of the spring, it goes all the way through the inside of the spring and connects to the top. I don't know if that will affect what you're doing right now, but just so you know.
So the spring has a hollow.
Exactly. Yes, you can kind of see it if you rotate it a little more, but that works too.
So inspect and section analysis for you to be able to see through things. So I can now hopefully
that is not
select this plane.
Oh, I was gonna say.
I can't because it's a
mesh, right? Yeah.
Yeah. We'll do it this way. That'll work.
There you go.
Okay, cool. So I can see it coming all the way through. Okay. That's cunning. I was wondering how you're doing that, because you had to have it all the way through on one side, didn't you?
Yep.
So you're doing it in that direction. Okay. Okay, cool. So it doesn't make too much of a difference
at this point, right? Okay.
Point.
Yeah.
We should probably draw it in though. We'll draw it in. What do I do? So we'll call this 5. This can be 15, 20. And we'll go midpoint. Okay, we won't go midpoint. Why? Have I got I've got a coincidence to it. Where? You shite. There we go. That's one thing that's a real pest, is figuring out when you suddenly have a sketch that's fully constrained and it shouldn't be. And you're like, where have you made a joint that I didn't want one?
Right.
So this can stick out. We'll call it 30 for now. 45 looks rightish. Okay, so that's our spring part in there. So you've got these angles here as well. So we'll try and account for those. So that's way longer. Okay.
Right. Yeah. Okay, so that top bigger rectangle is the spring, right?
Yeah. So that's the spring. That's your rod going all the way through, and I'll create another one for this rod here, but we'll do that in a moment. We'll just try and figure it out as we go.
Yep.
We have a motor mount. Okay, so we have to count for that. Okay. We'll start how we did with the motors. Bop, bop, bop. So servo.
So you're gonna draw the tibia at that angle so that the spring is vertical. And I know you said that earlier, but yeah, okay.
Yeah, because the spring is the complex thing to draw. Drawing the rest of it isn't as bad. But yeah, you know, it would be preferable that you can do it all as one, I guess, like keep it along the axis as one, but I don't know how. If chat knows how,
Yeah, I
welcome
mean,
to.
why not just draw the? Well, I guess maybe I know the answer to
It's
this, but just draw this. Just draw the spring thing separate, just off to the side vertically. I mean, that's what I did in
you,
Blender, but
yeah, but this is where you've got dimensions driving other dimensions.
right.
So you've got that length of the spring driving the dimension for um, between here and here, right? And also between this actuator is driving your offset to the switch.
Sure.
And
Yeah.
that, yeah. So I'd prefer to keep it all as one,
Okay.
just so you're, otherwise you're going to have where uh, you could do it as parameters, where you have the spring length set and have that set, and yes, do it as multiple parts. But your advantage in this case would be that you keep the servo horizontal, and that's about it. I don't think there's much other advantage to it in this case.
Mm-hmm.
But if you had much more complex design in this area, or with this leg, then it may have been worth to keep it, or it would only be in this area because this is the only part you would be keeping horizontal.
Right.
Because like this is still on an axis, so you're going to have to deal with it anyway. So we may as well keep the complex thing vertical, keep the less complex stuff not.
Okay.
Yeah, we'll rock with it for now. You can decide when you're redoing whether or not it's worth it. Servo height, depth, God, wish it said no, not that one. Width is what I called it.
There you go.
Probably name these something.
Dude, I don't even know what I would name them. Like, height makes. I know which one height is.
Yeah, yeah. It's the other three.
It's the three. Two. It's the other two. Yeah, like
the other 17.
Yeah.
Servo set. Okay. All right. So we can pop this into position.
Yeah, I like making the servo just with parameters instead of having its own model, because like I could like change the servo completely, and everything would just like fix itself hypothetically.
Yeah.
That's really cool.
Yeah. Okay, so we'll just do it blocky as for this. Or blocky-ish at least. And we're through here. Perpendicular. So this is where...
Oh, yeah, go. Yeah, you're fine.
So this is where it starts not being able to use horizontal or vertical. I'm now having to use perpendicular and parallel. So,
okay.
Yeah.
So what if, like, as you draw this, let's say I wanted the curve of the leg to not curve this much. But so obviously the spring would still be vertical. I guess you would like shift the spring over into to the left and down, and then could you somehow rotate the top left of this whole thing? Do you know what I mean?
Yeah. So this is pivoting.
Whoa! There. Yeah, you can. Holy crap! Okay.
You can see it.
That's so cool.
Breaking as we do it because.
No, that's fine. I mean, just the fact that you can grab that and just rotate it. That's.
But
sick.
yes, so this is all going to rotate, and this is also moving in. Should be in 3-axis. Yeah, sorry, in 2-axis. So this is currently moving in 2-axis. Yeah. We're going to lock this down with some dimensions driven off of here, because for your kinematics, you know.
Okay.
Yeah, from your. Yeah, for your kinematics, you know, you need between this point and this end effector point.
Exactly, yes.
And you need it in its compressed state. So
yes.
You want to set this up in its compressed state and get your measurements there, and that is what's going to drive these curves and everything.
That makes sense.
We'll work towards that in a second. 4, 5, and 8. 8 sounds good. This should be tangent. Yeah, tangents, that's cool. This should be that. so we're going to need some allowance for that body there. I think I'll drag this up a bit. What's that end of that one? So this is our box part at the very end.
Yes.
This part here. Oh, is this spring part of this?
Yes.
Oh,
Exactly.
I see. How are you holding that in?
Screws.
How's that? But how's that screw going through? You've got a shaft in
Yeah,
the middle.
I know. So.
Okay, so we'll do screws each side of it. So.
It's there's a very very tiny screw that attaches it to the tibia, and then a screw that goes through both parts to attach both sides together, and it's a little bit hidden.
So it's finishing the end of the screws finishing there before
Yes.
touching the shaft.
The to attach to the tibia, yes, and then there's this spring thing it's two separate pieces that are screwed together, right? And that screw is here.
Okay.
But...
Oh well, I'll run with what I'm doing, and I'll let you. I'll let you
but you don't have to. Yeah, don't worry. I mean, yeah.
Okay, so we'll allow for that spring. So we had 25. So we'll call it. Sorry, we had 20. We'll go 25. Need to allow for that. So that needs to come up. Just do that. Coincidence with there. Okay, so now I can set these dimensions to the end point. So 150, 150, sure.
Could you draw like a line? I think that would help.
Yeah. So you might want to be doing. So you'll have a line right between the two. You'll probably be doing this as a rounded end.
Yes.
But now that we've got those dimensions, you can either have this line, so you've got driven lines, and that'll just tell you what the dimension is.
Although I would like to be able to change just that line, maybe, and then have the whole length of the tibia scale down, but still look kind of okay. But
yeah. So it will just be deciding what your second dimension is. So you might have that line there, and then an angle. So instead of these two, I can do. I'll do it how you wanted to. So we've got that line there. That's 250, and then we have a dimension between these two for 25 degrees. So what have we still got movement on? So we can still go back and forth. So you'd still need another dimension for the height of it, I guess.
Okay.
Yeah. Bit messy, but we're getting there. So yeah, you just need to do enough dimensions to constrain it properly. But you can have that. You can drive this angle how you want to.
Yep.
Whether it is by an angle dimension or by a, you might want the top of this arc to be vertical with the top of the foot or something like that. I don't know. You've managed a much nicer design than we're at here. So
if you want to make yours nicer really easily, just increase the length of the top arc. By a lot.
Yeah, it's too stubby, eh?
Move that. The top arc point needs to just slide to the left a lot more, and then it'll look better.
I want this to. Hold up. We'll fix
this. This is good first. Though. No, seriously, just watching you try to figure this out is definitely helpful, I think.
Hopefully. So we want this to be in its compressed state.
Yes.
So this part here, I'm looking at. I guess we're looking at between this top dimension and that dimension there.
Would it have made more sense to draw the spring in its own sketch, or no? Because it's like a part of the tibia, so we don't care.
Possibly. So I'm not doing just the spring. I'm trying to do this.
Yeah, I know. That's what I meant.
This whole part as one.
Yeah.
Like I'm just trying to get the block of where this is going to be. It may have been.
Oh, if it's just like the block, then yeah, I guess in the same sketch makes more sense in my opinion.
Yeah.
You're not actually drawing the spring. Yeah.
No, because area for the spring is driving the shape of this leg,
Yep.
and vice versa.
Yep, that makes sense.
That's the only reason I'm keeping it in as one. I'll try and get this to a point it doesn't break so much though. Right in that. I don't know why I've got this gap here. Yeah. Okay, this. Okay, so I want that to be. Do you know how much travel you have? 3 mil?
I can.
Yeah, we'll guess at 3.
No, 10.
More?
Yeah.
Jeez, do you have 10 mil of travel on the foot?
Yes. I mean,
Why?
Why? Because it. I'm also using it as shock absorption. So.
Oh, okay.
Yeah.
How do you handle that with the IK though? Because as soon as you're not compressed.
I'm assuming it's pressed in all the way.
Okay. Okay. Yeah. I guess once that switches.
Sorry, I laughed because I was gonna say I just completely ignore it, but that's not true. Yeah.
Hey, it's a strategy.
Yeah. Just pretend it. Yeah. Oh god.
Yeah. Oh, that should be vertical. Sorry, so I'm just trying to constrain the spring design to the end of the leg here, and then I'll move it around to make it look better.
Okay.
Sort of here? We'll go with that. That's good enough for now. It's not.
That look great. Look at that. Nice. I look back up and that's great. Can you see my mouse when I do? Oh yeah, you definitely can. This line should definitely keep going straight at least until here.
Yeah.
Everything else is great.
I get you. Yeah. So we could do those. We can do these
equal,
two.
Right.
Equal.
Yeah. Yep.
First, I'm going to fix this in position though, because if I
you're fine.
squiz this around, it's going to squiz around the rest of it. So I've fixed that position there, and I want to fix the height as well. You can see I'm coming back to doing it that way.
That's fine, yeah.
You can do what works for you. So we've still got that rotation there to deal with. And
because the angle's not constrained, right?
No, so the angle's not constrained. So we can do, we can change this as we want.
Oh, I see. You're putting it, and now you're going to constrain it. Okay.
Yeah. So instead of constraining it by angle, I'm just going to go coincidence to here, and I think that'll fully constrain it. Yeah. So yeah, it's not pretty, but you will do a much prettier version when you do that. Yeah. Okay, so that's our last piece.
Tibia.
Last piece. Do I want to do that servo? I guess I probably.
Yeah. So would this top-down sketch be at that angle? It wouldn't be the top down of all the other ones. Okay, that makes sense.
So we are going to need construction geometry for it, and we want our plane to be, along this way, but slanted down, don't we?
Yeah.
So, and I want that plane to be bang in the middle of the servo, preferably, so it makes sense looking at it.
Sure.
This is going to get a bit funky because it's, because we've got the curve and everything. So in reality, you'd probably have 2 planes. You'd have one for setting up the servo and then a second one for setting this up.
Okay.
Yeah, I think. I don't know. We'll see how we go. Okay, sorry. If I go back into the sketch, I'm going to create a line just through the midpoints of the servo line and do it as construction, and then construct a plane along path wherever it is. There we go. And select this path, and I can select the distance as 0.5, so it's right in the middle. And that is that. And I can now draw on that as a midline to that servo.
Huh. Wait, what path did you select?
So I selected that one that I just made in the middle of the servo. So I've made sure that
the plane is going perpendicular to
that? Yes.
How did it know?
If I rotate like that, is that helping?
Yeah, no, I see the plane. How did it know to make it like that? If you just had one line.
Yeah, so...
I guess. Don't know. Oh, no, that makes sense. I understand. Okay. Yeah, I see it now. Okay, nice.
Yeah.
You have one line, it's perpendicular line. Yeah. The plane can rotate, but the plane's infinite, so okay.
Yeah, but it sort of it tends to fix itself in the right direction, so you're
Yep.
generally pretty good to go. I do find sometimes the midpoint will break though, so you need to keep an eye on that. If you have issues with, say if you have issues with the sketch, just double check that the midpoint's actually where it should be.
Okay.
Like I've, yeah, it just may break.
Okay.
I find that the easiest way to make construction planes is that using the through line. You know, you've got that and the with two lines and other options, but that's one of them.
What
Okay.
using the through line? What is that? What do you mean through line?
So your other options are like plane at angle. So if you're trying to do
like the constructing a plane through a through line. Where
yeah,
there
so
it is.
just
I
your
see.
different
Yeah.
options for creating planes. So you've got through two edges might be helpful, or through 3 points. Through 3 points is difficult because that means you've already got things in 3D.
Yeah.
But yeah, I find plane along path is really helpful, and tangent plane is really helpful if you're trying to do something on a rounded surface. Those two are pretty good, as well as plane at angle. So you can use that on a single line. I'll just show you. So we can choose this line. We've got a plane there now, or we can rotate it around. So if you're trying to do a 45-degree cut,
Sure.
Through something, like you've got a design that you're, say, doing an X look through it, you could do this on the outside edge of it and do an X cut through it.
That's cool.
If that makes sense.
Yeah, no, it does. I'll be right back. I need to let my cat out.
You go for it.
Okay. I'm back. He was locked in the bedroom. Okay. We're good to go.
Safe. Okay, where was I? I was drawing this stuff. So this is our top-down servo.
Right.
A side-on servo, isn't it? So we want that and the bearing, just the same as we've got over here. Yeah, same as we've got over there, sort of same. Bearing, what? 5. Definitely should have done parameters for the bearing. We'll ignore that.
You got the servo, it's fine.
I think I've driven off of 3. So here I need to do a dimension between this midpoint and here just to set where that is. So I can either create a line like that and put it as construction and then dimension that way, or you've also got the option of creating a point and doing that as a midpoint. So you can see that's got the midpoint icon and a point there.
Yeah.
So that can be handy in certain circumstances. Just another tool we've got there though.
Completely forgot about that. You can just place points.
Yeah. It's handy when, say, you've got a curved line going one way and a curved line going the other way. For example, we have some intersecting. We've got two curved lines like this, and I want to have something drawn right to there. I can create a point on this line and also coincidence it to this line, and now it's at that intersection, and you can use that for whatever other lines you're drawing off of there.
Could you have just placed the point at the intersection? Or
it will only grab onto one line at a time.
okay.
You'll still have to do a coincidence to the second one.
You'll have to. Okay.
Okay, so we've got that. I want to project in that and that. So that's collinear and that is collinear. I'll set that one.
So you're making the bearings collinear with each other, which makes perfect sense. I don't know. My intuition would make the bearing line up with the femur, I guess, just because that's what's happening in real life. But
yeah, so I'm just grabbing from the sketch up here where I've lined up the servo. So I just want these bearings and these servos to be in line.
That makes more sense, honestly.
And then I'm only having to deal with what to project that in as well. So yeah, using those other dimensions that I've already set, and I need that in the middle. So that is the general layout for where the servo will go. I'm not sure we actually needed that sketch, but hey, well, we've done it.
What do you mean? Why wouldn't we need it?
I guess I guess we will, because we're setting this to the width of the servo, aren't we? I should probably finish that with the width of the servo. Yeah, and I've kept that in line. Okay, cool.
Okay.
Sorry, just struggling.
No, you are.
I'm impressed.
You are fine.
I'm impressed you managed to do this for 6 hours at a time. Like, that's hard work, mate.
Oh, are you talking about yesterday?
Yeah, like your last two streams have been what, 5.5 hours?
The first one was 4.5. The second was 6.5. Yeah, yeah. Well, when I get focused on something, it's pretty easy for me to just keep doing it.
Yeah, good on you.
Because ADHD, you know how it. Well,
it's a brilliant thing, right?
Well, you know.
I'm not entirely sure. I don't think I want a 3D sketch of this yet. So,
okay.
I'm going to leave this here for now and
what do you mean 3D? What do you mean 3D sketch? Because I know there are 3D sketches.
I don't know if I need my second axis sketch. This one here. So I don't know if I need that for this. Yeah, because this has so many curves on it, I don't know if I'm going to need it, but we'll figure that out once we get there. I think we'll leave this at this for now.
Well, like, okay, so the top-down sketch, right? You'd want it for the thickness of each of the tibia parts, right? So
yeah,
wouldn't that just be 2 rectangles?
Like, we'll be this will be dictating, the thickness of
the
this
servo, yeah.
part here, but we've got the servo there, so I don't think we really need any more, because we're just going to sort of grab this and extrude up to the servo lines. So
right,
we'll see how we go.
Okay.
At worst, we just pop back into here and we add things as we need.
Right.
We can continue using this as a master. Okay.
Nice. All right. So that was the master sketch.
Yep, and we will save that just for... We should probably actually save once in a while. Okay, but we are still creating in this same one. Okay, I'm going to go grab a drink before I do more talking.
Yeah, you're fine.
And we get to the next bit of it. That's all good.
All right. So we finished the master sketch at 1 hour and 30 minutes. Perfect. I'm gonna make sure this VOD has chapters, so whoever's watching it after the fact can skip around a little bit. But yeah, oh man, Uger, however you pronounce your name. Sorry for butchering it, but yeah, I'm sure a gear wouldn't be too hard to do. Once we finish this, honestly, I could probably show you how to do a gear, but it's just you make one of the teeth and then you rotate it around a point. Yeah, guys, I hope, I mean, he'll be right back, but I hope this is useful. I think the VOD is going to be very, very useful. Being able to like skip around this and I don't know, just see how he does it. But it's cool to see how he like approaches making such like a complex robot, whatever you want to call it. Yeah, exactly, John. I agree. And like I can definitely see myself doing this, but I am very curious how these like top down plus side view sketches translates into the actual thing. I'm very curious because like I don't know, I potentially I might just might constrain the servos. Like I just place the servos in the sketch and that's it. Like nothing else, or maybe like lines to the rotation points, or something. We'll see. Maybe this is too much, right? I don't know.
Okay.
All right.
It's all right. We'll see how we
Oh,
go.
you're
I may
fine.
run out of time for this, but yeah, we'll see how we go. Okay, so now we've done that, we will crank through the body.
Yeah, you know what, the top, I would like to see how you would approach something like that. And I think I have an idea, but
That curve top?
yeah, and obviously you do not have to make it that detailed, but just like an oval at the top and then 6 kind of curved leg things coming down.
I did actually want to show you, so
Yeah,
yeah, we'll
yeah,
do
okay,
that.
perfect.
Okay, so I'm in the body. I don't actually need to project everything in. I can just use it straight off that sketch there.
Okay.
So we will go
Hold on, what sketch
down.
where are you right now? What sketch are you?
So I'm in a new part
Oh,
that I've
okay,
created.
okay, yeah,
So
yeah, yeah.
this is the main body, I should probably call it.
So you made a new component, right?
Yeah, new
Yeah,
component.
okay.
So I'm in this. I don't, because I'm not modifying that sketch, I don't actually need to.
But it's just there because yeah, okay, cool.
Yeah, it's just there because I'm showing it from this master sketches.
Oh, okay. All right, I see.
So again, this is the timeline thing. So I'll do this and then I'll show you the actual timeline.
Okay.
So I want this to come down and hold the servo a little bit. So I want this to come down to that point. So I'm going to go to Object, to the corner of that servo there. I actually want it to come back up as well. So I'll do 2 sides, and this one can go to Object to the top of the servo there. I know you're doing this in multiple bodies, but you're going to have to forgive me and let me ignore that for now. So that's that. That's the rough of your body. From now you can do your cutouts inside to hollow it out. So, yeah, I'll do that now. Why not? So allowing for all of your electronics in it.
Yep.
And yeah, creating the outside and then cutting it away.
Yes. Yes. Exactly.
And you'll notice I'm turning these into construction so that all of this is a single click. Fusion isn't very particular with it, but if you were using SolidWorks or something, it really drills it into you that you must have only one. It drills it into you that you must do that, so you only have one area of selection. But Fusion's pretty flexible with it.
Okay.
So I can offset this at like -3 if I want that to be 3 mils thick at the base, say. And then you can go in and make this body. Say if you want to do, should get rid of that. So you've got this split here, right?
Yeah. So we've got the bottom part, which you basically just made. The top part is separate pieces.
Yeah. So you've got.
I guess it doesn't really have to be. It's just to make it easier to Oh, actually, it kind of. It doesn't matter. Yeah, but yeah.
I'll give you an option anyway. So just for some more tools that are available.
Well,
So
hold on. So this is how I would do it. I just watched this video. I think I would cut the top off, right, and then I could just edit that top part, and it would still use all of the dimensions from the previous stuff we've done.
Yep, that was what I was about to do. Yeah.
Nice. Okay. Cool.
So you can do a offset plane, drive it down. Say we'll call it 10 mil, and then you can do a split body. Beautiful. So select body, select the plane, and now you've got 2 bodies there. So body 1, body 2.
Yep. Perfect.
And you can hide your construction, and then yeah, you can work on there and do your cuts down and cutting that out. For the oval at the top, we'll try and get something. I'll show you how I'll do similar. I don't think it's going to be.
No, please, just get the spirit of it. Yeah.
Yeah. So I'm going to go back to before I did that cutout, as I think it will make it a little bit easier.
Sure.
So I'm going to create a sketch. I'll do it on this plane. That'll be easier, I think. So I'll do that line. Want this should be coincidence with the middle. I want this offset from that a certain amount, so this is another place I can add a point or a line. So I can add a point there and a point there in the middle, just so I can actually dimension to the tangent of that line. Tangent, I think, yeah.
Yep.
Do the same with that. We'll call that 10 mil again. This is construction. So I'm going to do this as, I think, 2 3-point arcs. I think 2 will do. I think I'll need a third. I don't know. We'll try it as 2 and see how we go.
Okay.
Oh, I don't actually need that to be tangent to that. No, I don't. Okay, yeah, we'll be able to do it as 2, I think, now. Sorry, so I don't need that line there. That's cool. We'll just ignore that instead of deleting it. I do want these to be tangent to... Oh.
Nice.
Not quite what I'm after. Okay, we'll set a dimension first then. And make these tangent to one another. Here we go. So then we can set the size of that as well. So, what do you say? That is fine. Need to make sure I'm editing the original one, not the references. So I would do a revolve around like this. Instead, I'm going to. I don't want it to go the whole way, so I'm going to do a partial revolve and 180 degrees.
Okay.
And that should join it on like that. And then I am going to. I think I want to fillet it now. So we'll give it 20, 10.
Oh.
10, say? So it's more looking alien bobblehead, but
hell yeah.
Hopefully this will be a premise. This will hopefully be sort of a workflow for you to recreate it. So I've got there. I now I want to shell it out.
Yeah.
So I say I only want this to be 3 mils thick. How should I do that?
Yeah, and then I'm curious how you do the little arms or legs or whatever you want to,
Yeah, well, you want your arms to be part of this, don't you? So I should have made it higher, maybe.
I just want each one to like attach to kind of like where the servo is. Right?
Yeah, because you had it coming down at a much shallower angle.
And then the front is the front is a shallower angle than the back. Yeah.
Yeah,
or actually, other way around. Yeah, other way around. But the back is shallow. The front is steep.
That's up on top, though. Okay. So I'll go back to before I made that. So we'll create another sketch on top. We'll do it as so I'm wanting to do the base feet, I think.
Okay.
We'll see how this goes. I'm not gonna lie, I'm not real great at organic stuff. I don't have to do it very often.
Yeah, I mean that's why I'm curious, like how you would even approach something like this in this kind of program.
Okay, I'm just gonna make it blocky just to.
Yeah, no, please. Yeah, please.
If you really, I'll do this and then I'll show you the other options you've got. Okay. Like you do have a mesh editor in here, so you can design it in the same way that you do in what was it you were using?
Blender.
Yeah. So you can design it in the same way you do in Blender, because you have the option to tessellate. So take a solid or a parametric model.
Oh wow.
And turn it into a surface body.
Huh.
So you could sort of get the rough idea of it and then turn it into that, and then you have the option to just grab those endpoints and move them around how you wish.
That's cool.
So you do have the option of doing it how you used to, and to be fair, that may be the better way.
I honestly, I don't want to do it the way I want it to be. Like, how do I want it? I want it to be smooth. I want it to be even more organic. I love having all these like fillets and actual curves, and it's just so much nicer. So, like, I ideally I have like an oval kind of top with 6 just like let's say legs coming down that are just smooth.
Yeah.
Like, so please, like, you do not have to copy the original design at all, but just those
No,
two
I'm just
things.
trying to see how close I can get it to it. As I say, like, I'm not very good at this, so you're going to have to give me some allowance.
Like,
here.
I wonder if you just made the top and then drew like some lines and then made like a pipe from the lines or something, does that maybe, or a loft that follows the line, or
like pipes coming down.
Yeah.
Yeah,
I
you
don't
can
know.
do yeah, that is an option. You could do sweeps. So, say if you wanted this to look like a tube frame cage, like roll cage or something on top.
Yeah.
Yeah, you can do sketches and have it follow the way down. So I try and avoid 3D sketches in Fusion because I haven't had
It
a
would
good time
definitely
with
be
them.
3D. Yeah. Yeah.
Yeah, but you don't actually need to. You can have this one because that's on the axis, and then you can create a plane at an angle and draw this and possibly that one as well, or offset those planes how you want to get into this position, and then you can draw that line down, and then you're just drawing a circle at the end of it and doing a sweep down.
Right.
Yeah, we'll see how we go with this.
Okay.
To continue just for giggles. Let's see, I've got no line to mirror off. So we'll do that. Well, extrude it, and note that we've got those extra little bits, so we have to go and grab them. Let's make sure they're included. That can really get you if you've got like a really tiny bit, like in a corner of a curve or something that's coming down. You might have, just a slither of a piece that you're misclicking.
So that happened because you clicked the top of the top face and created a sketch on it, and then you drew over the edge.
Yeah, so Fusion, Fusion just sort of counts that top face as, actually I want that to be a new body, not a join. Fusion sort of counts it as one piece. One moment.
Okay. You're watching this while in a Burger King. Nice.
Alright, sorry, I'm going to be looking after the kids at the same time now, so
okay.
This probably can't last too much longer. Okay, so from here I'll do as I did before, so I've got that curve. This is one thing you can do. If I could right click here, I can redefine the sketch plane, so I can move it up to here.
Whoa.
But in doing so, pretty well everything will break. So all of these green lines, they are now absolutely useless to me. And you can see it's referencing the green lines. So if it ever loses a sketch plane, it will break, and it will break like this. So if I do any changes below now, like if I change the length of this, it won't update.
That's
so
not
it's
good.
one thing that it's one thing you really need to keep an eye out on. And being Fusion, it still counts it as fully constrained, which is just great.
Why did we redefine it?
So I've just moved it from the surface here to the surface here, as I'm just going to work it as this one.
But doesn't that just break everything now? Like, or it will if. Do we want to do that?
I want to do it on this body, yes,
Yeah.
because I've created a new body, so I'm now working on just this piece.
Yep.
And trying to shell it out this way. Yeah. But yeah, it's one thing to keep an eye on is if you do have missing faces or sketch plane lost, you as soon as you have to redefine it, you have to pretty much redo all of your references in that sketch. It's a real good time. A real good time. Makes me so happy when it breaks on you.
Oh, so but the other stuff we did is still fine, right? It's just you just wanted like to duplicate the sketch up here.
Yeah. So I wanted to move the sketch up here as I'm going to now revolve around this axis here, actually, and you can see I'm still got a little green dot in the middle there that I'm constraining on. What is this? What is this? That. You can bother off. So I wasn't even constraining to the middle of the thing there. Not sure what that is. Oh, that's my centers. Okay, so that is coincidence. Okay. And we'll try and do this. We will create the points. A point and a point. 12. Nope. Okay. 20. Nope. 2 define. I'll get rid of that. That's real nasty. Drag these back down to something that's a bit more reasonable. There we go. Ish. Nope.
Yeah, that's
that's a hard no. Still no. 250. Okay, I can do 250. That's allowed. You do find sometimes as well with Fusion you have to work your way back down.
yeah.
So you see how it glitched out on 200 there. If I'm working my way back down, I can now do 200.
What?
Without it glitching out.
Oh, yeah. I see. Okay.
Because it doesn't iterate its way down. You know how you had a lot of points for iterating where your line was going?
Yeah.
For your leg movement, it doesn't iterate down. It just slams straight to that new position. So you'll get that every so often.
That makes sense.
Okay, I'll run with that and see how we go. This is gonna look real funky.
I'm curious at how you're gonna do this because from this.
Poorly,
Yeah.
very poorly. Maybe not so much on the sides. We'll do this. Maybe 50. Yeah, it's going to be poorly. As I say, I'm not very good at this sort of thing. Okay, but yeah, we've got that. Okay, we've got that. Okay, so that's our outside size. We want to cut it away and make it a bit prettier. So we'll do this and some lines from here. I'm trying to click and drag on the line, and that will create an arc. Just another thing instead of having to go back through to it.
Wait, so you were drawing a line and you clicked and dragged, and it automatically made an arc?
Yeah. Cool. So I'm going to mirror all this, but if I have that line tool, I can create that line where it's now doing a line. But if I go back to the center, click and hold, and drag out, it's now an arc.
It's a tangent arc too. That's cool.
Yeah, tangent arc. So you can then do that again, and I think you can probably do it again. So yeah, that's one way just to skip having to go back and forth through tools.
Yep.
I think this is the only line I need this to be tangent to it.
And then 2 mirrors.
No, I do need collinear. That's the one. I'll do a line up here as well. And drive that into here, and there, and X, and if you can sort of see how I'm skeleton thinning it down.
Yep. Yep.
I'm not on the right spot there. I should be on that straight line. That's breaking because it's tangent. Sorry, one moment. Cool, sorry. I'm now on child duty.
It's all good.
Yeah, this is one thing you can enjoy. I assume you don't have kids yet.
Not yet.
Oh yeah, mate, enjoy this free time you have.
Yeah, I am.
Enjoy it because you have it. Yeah. So 10 and that 20. That's that. Now I'm going to want to cut all the way around, so I'm going to project in. I wanted to cut the outside out, so I'm projecting in these outer lines, and going just all the way through the outside of it. I'll do that vertically. Okay, and I'm going to do my mirror lines again. That's how I love mirror lines, eh?
Yeah.
I swear I don't use this many mirrors normally.
Oh, I mean this whole thing, every piece is mirrored at least once.
That, and that. This is a lot of lines. This is a bit disgusting. That, I should have had a line across there. No, I don't. I don't need it. And mirror one more time. Blah, 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 blah. Didn't actually need that line. Please do. Yeah, that's all of it.
Nice.
Okay, so there we go. So we can now cut this out. That
and then extrude it. Nice.
Okay.
All right.
So all right. Well, are we in two pieces there? We are in two pieces. We should not be, because I created a new thing when I did that revolve.
Right.
So I want to turn that back into join. Yeah, is that joined? That has joined. Okay, cool. Yeah, again, that was after I moved it. So moving that sketch plane again and having not the correct thing showing. Anyway, okay, so now we have it like that. So it's a bit bulgy, but you know, you get the idea. We can fillet these edges, not that one yet. Put it around here. I'll do two lots of fillets, just so we've got longer on those sides. Oh, what has happened here? There we go. 10, 10's good enough. And
how would you, I'm not saying you should do this, but how would you make, instead of filleting, how would you make that edge just go to the bottom edge, if you know what I'm talking about? The curved edge.
Instead of being vertical on it?
Yeah. So if you undo the fillet.
I get what you mean. So
okay, you get what I mean? Yeah. Okay.
Yeah, instead of this being tangent to a line here, you want this to be sunk down in. So you're wanting to start that. Why is that not working?
Wait, sunk down in? What do you mean? Here, I can literally just show. So this edge goes here, for example.
Oh, okay,
yeah,
all the way out there. Unsure. It's going to be how you draw these outside edges and how you draw this.
And how I draw the dome thing, right? Okay, so that's where I change it there. So yeah, that makes sense. Okay.
Yeah. So
you don't have to. I'm just but I was wondering if there's a way to like do it after the fact, but probably not. Maybe. I don't know.
I don't know. Just to say as well, if you don't want, like, this is coming down and this is vertical, so if I wanted this arc sunk down more, I would have to start a sketch on a plane that's away from here. So instead of having the center here be my, like, this is my center of rotation here, I'd want to move that center of rotation down, and then that way, instead of having hard lines coming up, it would be...
Oh, right, because the whole thing's revolved. Oh, man, okay.
Yeah. But yeah, for now, I'll leave it at this. So I've got that, and I think the last thing to do is shell. So we select this bottom face, and we select a thickness of, say, 5 mil. Oh, that's not right.
That is not what we want, yeah.
That is not what we want. Okay, how else are we going to do this?
Do another revolve
Okay.
cut.
Yeah, I think we will. So where did I create that sketch on that surface there? I'll come back along before my fillets and before the extrude. I'll just do it in this revolve sketch, why not? So I think I can go offset and offset it in a bit. That's a bit disgusting. Oh, I don't want change selection, so I can deselect that so it doesn't do
I
the
was
whole
gonna
thing.
say, yeah, you only. Oh, that's cool. So you only want to
And
offset that. That's perfect.
yeah, instead of now dragging that in as well, I've got it coming to that line, which is what I want. So I want that 5 mil. No, wrong way around. -5 is what I'm after. -5. Okay, so we'll do that. So we'll finish that, ignore the sketch for now, and go back to where we've combined everything. And we can re-show that, do a revolve around the whole thing. It's cool. And then I can
That's
just do
great. Yeah.
an extrude on this top surface and go to the bottom surface. So there you sort of go.
Hey, it's one way to do it. I'm definitely not going to do it this way,
Yep.
but it's cool seeing just that, like using revolve like that, and then cutting into it.
Yeah, as I say, this certainly isn't my area of
No, don't
expertise.
worry about
Um,
that. I think
I
I
do,
think I know how I'm going to do it. I'm gonna somehow make the top part and then draw lines and then like make lofts along those lines somehow. I don't know, but or
yeah.
you know what? I may just export it. No, I may import it from Blender. We'll see. We'll see. But
If you do lines, like as I say, I try and avoid 3D sketches in SolidWorks, but sorry, in Fusion.
yeah,
Um, just because when I last used them, they were really awful to use.
I don't think it would be 3D though. It would be one
Uh,
sketch per line,
yeah,
right?
seeing you're sticking with if you're sticking with axes, it's fine. But if you wanted like it to curve, you know, down here and then a second arc around and down, you would need 3D, and you'd
Okay.
have
I don't,
like a
fortunately, want that. But
yeah.
if I did, yeah, that would make sense.
Um,
So, can I make a
but if
2D line and then have a 3D loft, or aren't all lofts 3D, and then have a loft follow that line?
yes, yes.
Okay,
So when
good.
you use
That's yeah.
the loft command,
Or sweep, maybe? I don't know.
so
What is
I'll
sweep?
just as an example, I'll create a quick sketch here, ignoring Fusion being Fusion. So I'm going to do this. I've got to make sure this is concentric, or yeah, centered on this line that I'm going to use. We'll do it as 10, and now I can create a sweep you're after, right?
What's the difference
And
between sweep and loft?
so loft
What
is
the heck? Oh, that's sick. Look
so
at
if I do that
that.
as a new body, say, I can then hide that other body, and then you've got that. So loft is surface to surface. Sweep is a sketch at the end of a line and then a line for it to follow. Whereas a loft is, for example,
Okay, I'd want a loft then because I want it to get thicker as it
uh,
goes, right?
sorry, I don't want to sketch there. No, I'll do it on a sketch there just to, we'll make this messy, I think. Yeah. Sorry, so for a loft, we have our first plane, which I'm going to use this one I'm doing this construction sketch off of.
Yes.
And then a second sketch on the construction. And I'm going to see just how hard this breaks if I try and do this. And then create loft. So I select the first sketch and select the first sketch and select the second sketch. And that's a loft. That's real disgusting because I've got all these legs, but you can do something like that, and then you can do multiple of them if you're if you've got like a shape of a fish, say, you would have that fish shape going along, like you do your side view, and then you do intersect cuts along that fish, and you do the different size ovals for the body,
Oh.
and then you'd loft from one to the next, and you could
Yeah.
do it all in all in a line, and then also use guide rails to have it stick to the top and the bottom of the fish.
That is something. Yeah, that's probably what I'm gonna do. It'll give
You're
me more
probably
control.
better off going and looking at a dedicated tutorial
Yep,
for it.
yep.
It'll be
Okay.
a better explanation than what I've done. Okay, we should just crank through and make this jointable, I think.
Yeah. So let me. I want to see how you use like the Coxa and Femur kind of sketches.
Yeah. I need a pivot point here, so I'm just going to be dirty in place of
No, that's
servos
fine. Yeah,
and
that's fine.
actual things. 32. Okay, I want this on that sketch plane, which is our top plane. So it's sort of handy, you can zoom out and that stays the same size. I'm just going to be dirty and do a circle to the edge here. Just to have something to tangent onto. And I'm grabbing that center line there. Can I grab that? I need to grab a point off of it. Project it in. Project it in. Here we go. 5. Oh, not 45, please, just 5. Join instead. Okay, so that's just giving me somewhere to joint off to.
Right.
So ignoring how dirty this is going to look, like this will be, you know, you'd have your servo mounting in here, you'd have, yeah, you'll just have your servo mounting in here. So you'll have your fixed servo, and then you'll actually use the servo to joint off of for your rotation. But
Okay.
I'm
Yes,
not
yes.
going to joint for the servo because I'll run out of time. So now I've done main body, I'm going to do the same thing with whatever that first one was, the Coxa. And now I can just...
So that cylinder is the servo?
Yeah, that cylinder is
okay.
going to act as my joint for the servo. So a little bit nasty.
Yep, that's
and yeah, a bit nasty, but we'll just ignore the problem for now. So I want
it's all
to
good.
be,
Yeah,
sorry, not 2 objects, 2 sides. So we'll call it, this lives above and below, doesn't it? So this goes up to the servo. So 2 object to there, it's different. And 2 object to there, so that's my outside shape for that. And then you'll do all your proper servo mounting for this.
Yep.
So you've got your yeah, that's just your outside shape. You've set your width, so this is all driven from that master sketch again. And just because I'm using this disgusting way of jointing things, I'm going to create a joint again on that top plane. I'll hide that, create a joint on that top plane, and still using those master sketches, I can do a circle in the same spot, and I just want it to touch that edge just so it becomes one piece. So another thing we can do is project, include, and intersect. So this is where this plane intersects this body. So I can grab that line there instead of projecting a line up or down. So if you've got an organic surface like we did for this body here, you might want to draw sort of 10 centimeters up from it and grab all the edges. You can use intersect to grab all those body edges at that plane. So we'll do that.
So what did that just do? Like where? What did it just make?
So,
I know what it did, but like that line.
Yeah, so it's just made this line here.
Okay.
But instead of grabbing it off of projecting in a line from the top or the bottom,
you got
it's
the
cutting through. Yeah, it's cutting through this face and creating the line by that face. So it's just a handy way of doing things. P, project UN, coinky dink. Sorry, it's starting to fail. Oh, I've midpointed it there, that's why it's not moving. So I don't want it to be midpoint. And I want these two to be collinear. This could be, say, 10 centimeters. And this can be something, we'll call it 10 just for, alright, better than that. 15. did I draw that on the body?
What are you making right now? Are you making the servo?
So I'm just making something in place of the servo to joint
Yeah,
it together.
yeah, okay.
So you would normally in this point you would be doing the rest of your servo mount. So
Yeah.
you'd be doing your top bearing hole, your servo horn hole, and how it all joints together properly.
Mm-hmm.
And then you will use the servo as your rotation joint.
Okay.
But because I'm not going to join the servo, I just want two circles that are in the same position so that I can use them to rotate around.
Oh, got you. Okay.
I don't want that to go away. Why was I going up or down?
Right. So you're drawing, you're drawing what's connecting to that other circle. I see.
Yeah,
so,
yeah. So,
yeah.
So this is just a bit dirty. So, when I come into the assembly, I'm just going to joint these two arcs.
Yep.
And
Oh,
that's
the
going
arcs.
to give me my rotation. Yeah, well, just because I don't, I could do it on the faces or just two of the surfaces.
Yeah.
You'll see.
Yeah.
We'll get the rest of the legs done just a bit dirtily. I'm sorry, I don't think I'm going to be able to do the foot today.
Oh, that's okay. That's okay. I'll have fun with that.
Yeah.
If you could, maybe if you could just do a really like not the whole thing, but just like how really quickly how you would do the spring part.
Yeah.
Okay. Yeah.
So we can add our next part, which was what's the next one down?
Femur. Yeah.
I'm gonna spell it wrong just to be awful. So I'll extrude this. Again, two sides, two objects to there and to there. Okay. And then sketch on this top plane and want that sketch showing. Where are we? I think the top, there we go. Just that one preferably. Just that one so I don't bring in anything from other things that I don't mean to. And I'm just going to project those arcs and those lines just so I can cut it back out. Okay. I hope this isn't too boring for everyone in chat.
I think you're not. This is good.
I have no idea what I was looking at, seeing sketches. You can see I like a lot of two object.
I do too.
So that's that.
So why did you have to? Couldn't you have used the original sketch for that cut, or because it looks like you drew a new sketch, or maybe wait, did you? Or was that the femur top? Oh, that was the femur top sketch, wasn't it?
Yeah, that was the femur top sketch. I had to project that in because you can see our reference sketch for it is on a different level.
Oh.
So I just drew a new sketch on the top of the body. Projected in what I need and went from there. I kept the side one because that's in the position it needs to be in.
Right.
So that's that. I will need some way to joint this. And have I cut that? Oh, I've cut that. Ha! Okay. So another thing to watch out for.
Yeah, I did this yesterday. Yeah.
Yep. So because I've got this body showing here, it's cut it. So under objects to cut, I can unselect it. And then we're good to go.
Huh. What do you mean? Because you had it showing?
Yeah, because it's still showing there. So if I go back in and reselect it, but if I hide it, I no longer have it.
Is that actually that's what you're supposed to do? Hide it, man. All right.
Yeah, it's not the greatest way of doing things.
I figured that out, but it just felt so I don't know. It felt like a workaround instead. But yeah, all right. I thought I had accidentally selected both of them or something. Okay. Wow.
No, so you've got the two places. You either hide it or you unselect it.
Right.
Yeah. I don't know. That's how Fusion do.
Yep. I guess it's just how it is.
Okay, so I want a pivot point in this one as well. Just something. Actually, I won't even bother. I'll just do it as a in the air pivot point. Okay, so that's that. We go back up to the top, and what's our next leg called? I didn't actually create the name of it. What's the end?
Tibia.
Tibia. Alright.
Yeah, you didn't name the sketches for that one, but that's okay.
What a lazy bugger.
I know.
Okay, so again, I'm just going to grab it and do the same thing, just two sides, two distances, and both to objects, and this is just going about the size of the servo. But I have this down here doing things, don't I? So I want to continue grabbing these parts. I think I want to grab the whole thing, don't I? I think so. I don't know. I'll hide it for the moment.
Okay.
Yeah. Okay, we'll go with that. But yeah, new body there. So you had this sort of tapering.
Oh yeah, don't worry about that. Yeah, no. Yeah.
So that's just the out. Oh, okay. You've got the outside sort of tapering in, don't you?
It's basically just chamfered or something. Yeah.
Yeah. So you've got options of doing it on the sketch and, just drawing a cut in and having it work your way down, or, as I had told you about earlier, a plane angle on tangent plane. There we go. So I can do it on the middle of the leg and get it in the middle, and then use that to cut it.
Mm-hmm.
But yeah, you're sort of cutting it that way, one way or another. Or if you want it dead in the middle of this, you can create a sketch with a line going right through, so that you can create a plain long path. But we'll do that. We've got the hole for it coming through. Just a line across to get it in the center. Call this for, okay, that's 10. Okay, 11. A little bit sloppy fit, good to go. Extrude and two objects there. I don't know if you're running that all the way through as a guide, top and bottom, but that's an option. I will, just for giggles.
Okay.
We'll call it -5. 10,
oh, that's 10. Cool.
Not 100.
So you can go to object and then offset it and then make it go a little bit farther. That's cool.
Yeah, so you can offset it front or back from that, which is quite handy. Okay, so we've got that, and then we've just got the foot. So a component. Master sketch of those last two, and we will create a sketch on that plane. We'll start with the shaft. Not doing anything. Nice.
Was that did you just project the one sketch onto this one?
Yeah, so I'm just projecting from that master sketch in, just to start with the revolve. Where am I? Sorry, getting faded, mate. I really don't know how you do this for hours. Seeing it's trying to select that sketch there, I'm just going to make sure I hide it. Otherwise, I might end up selecting one of those master sketches, and then I have things change that I don't really want to. So I want this to be a full rotation. I can then I actually want that to be a little bit taller, because I'm going to go up into that little bit I had. So this was in its compressed state, so I want to come all the way up to it. So I maybe should have done this in the master sketch. I probably should have done this in the master sketch.
Okay.
How have I done that? Oh, I made that horribly sloppy. Okay. Whatever, we'll ignore that for the moment. Yeah, I really wanted to, I should have drawn what I'm about to project in the master sketch. So drawn, Jesus, what am I doing? What am I doing? Oh, I'm in there. Sorry. Really losing it. That's the one. Okay. So create, project, include, and intersect. that body, not you. So yeah, I really should be drawing this a bit more complete in the master sketch instead of projecting it in like this. That's not centered. Okay, that's not great. That hole's not centered. Okay, I've done that in the wrong position.
Okay.
We'll do this collinear and then we'll go back and fix that and actually make it a right size. So we'll go back to this tibia. I made that sketch on the bottom, so that's fine. Instead of in the middle, I want to project in from my master sketch the center there, and then I'm getting that size as well, which will be handy. So I can do going back to that master sketch. So I just want to dimension this just to get that 5mm, and I'm going to grab this one, reference that, and add 1mm of tolerance.
So you can reference the driven. You can reference the driven dimension. That's cool.
Yeah. So again, once I change it back up in the master sketch, it will drive all the way back down, and I'll still be 1mm larger.
That's really cool. Yeah.
And yeah, again, I should have done that endpoint in the master, but we'll ignore that for now. So I'll go back to the foot, and my rotation there. So I want to reselect that. So I've got the full thing. So this is drawing it as fully compressed, aren't I? Do I want to be drawing it as fully compressed? I don't, because I want to draw the spring. So I don't want to go all the way to there.
Right.
Okay.
Right, because we just the compressed is for the IK calculations.
Yeah, we've only got it compressed for the IK. So
sorry,
I'm going to draw
it starts compressed, and then as it gets pressed in, it uncompresses. Does that make sense?
Yeah, it's stretching.
It stretches. So fully. When you say we actually mean fully stretched. Yeah, but the bottom's compressed.
Yeah, so I'm wanting to do this at its no load point. You know,
exactly.
I'm going to be drawing the spring unloaded.
Exactly.
So
yes.
I'm going to have to offset these ends of this rod, so that it matches the correct unloaded length. So in this case, this is going to be my travel length, right? Like this is going to be my bump stop. This is the rod coming all the way through. So I'm just going to offset this 2mm just so it's captive at the top and then it's captive through the bottom.
Yep, that makes sense. That makes sense.
And then back to my revolve, select. Are you going to let me do that? There we go. I'm holding control, by the way, to add more things.
Yep.
You can generally add on everything. When you're doing a fillet, for instance, I'll just show you this because it's something that's a quirk of Fusion. So if I add a fillet and then drive a dimension, I can't then select to add any more. But if I hold control, I can. It will hide it, and I can select things.
Yeah, I knew that, but I forget it like every 10 minutes. So yeah,
It took me a sad amount of time to figure that out. A sad amount of time.
Yep.
Okay, so the spring. All right, so we've got that round bit there. We want our base part. We're in the middle there, which is cool. We can hide the tibia. We don't need that. We've got our master sketches with the spring length. We're going to be mounting it onto that. Okay, so is this in the middle? It should be. So we are doing, because this is all part of the body, isn't it? So we'll do that, and because this is your center section, it's not the outside leg section.
Yeah.
You know. So I'm just going to bring all that in and do a line across as where the end of that center section will be. I want that to be at an angle, whatever. So I want that. you can bother off for a moment. So I need to start that down, whatever that. So I need to take off my travel distance for the start of where I'm going to connect to this rod. So again, I can be a bit dirty and create that, and then have this come down the same amount.
Yep, that makes sense.
I could also have drawn a line bit, like a construction line, and made it equal to that line or something. I want this to be in, and that can be the same, and that's my top fix point. Right, so that's my top floating fix point. This outside here, if I do the line across, is my, so that's my solid outside piece that you'll screw through, right?
Yes.
We've got the rod going down the middle, and this is the top fix point that that rod is going to attach to.
Yes.
So we're just missing the spring in between now.
Exactly.
Okay, cool. Okay, I want to finish this and extrude these just to begin with. I've stuffed this up because I've drawn those outer tibia pieces.
You drew it in the foot.
Yes.
Yeah.
So I'm drawing the tibia where I shouldn't be. Oh, the foot's actually part of the tibia, isn't it? It's not separate. Okay. I should have done all of this in the tibia sketch because it's all the same piece. Like,
yeah,
this
yeah,
foot
it's screwed together.
part of
Yeah,
that.
yeah.
Yeah, but you know, there's motion there, but there's not. It's one piece. I won't actually be able to show you the motion of it moving either.
Because it's one piece.
But,
well,
yeah, because
yeah.
it's one piece. You will have to go searching further for how to do an advanced spring like that.
Yeah, that, I'm sure. I mean, worst case, I just don't.
Yeah,
but you know.
It's always an option. Dang. Yeah,
so
dang.
why? So
I'll show you
why
how
can't you show motion? Is it because it's in the tibia?
Yeah, because I'm going to draw that spring as one piece, as the same piece as the tibia. I can't have motion between this part and this body.
Right.
I can't have motion between the plunger and the body because I'm going to connect it all with that spring, and that's going to be a rigidly fixed spring. Like it's part of that, you know?
Yeah.
So you could do it, you can create a second body separately that's just this top face and the pin, and then joint that on and show the motion with that would probably be possibly the easier way. But yeah, that'll be up to you to figure out.
I guess so. So what should I? What should I do? Should the spring be separate, and then how do I even do springs in this? I guess I'll find out. But
well, I'll do the spring now. So ignoring that I'm doing this as the foot, I should be doing it as the tibia because it's all technically all one part.
Yeah.
So I'll extrude this and just do symmetric just to keep things easier.
So what should be the foot?
The foot should be part of the tibia.
Oh, so you should just not have made the foot at all.
Yeah, I should just not have made the foot at all. I have done wrong.
No, that's okay. I just want to know like what should have happened.
Yeah.
Okay.
Yeah. So what is now the foot should just be the tibia.
Yes,
I should probably actually just get rid of the tibia and call it foot.
Oh wait, did you do anything in the tibia?
I think I just created that outer body. So
gotcha. Yeah.
There's not a lot to lose, so I'll just get rid of it. Hey,
there you go. Okay.
And you can see what happens. Oh, I had that setting that distance. Oh well. So the yellow is a reference lost.
Right.
So I have to delete that, and I'm now going to have to dimension this.
Yeah, I mean it's fine.
Just because I'm going to be cutting it out on this part instead. So that's fine. Okay, so we've got just the center part. You'll then have your outer parts. Figuring out as we go. The fun of doing this live.
Yeah,
God, what are we up to time-wise? Do you know?
This specific 2.5 hours.
Oh fuck.
Yeah, it time flies.
Yeah. Yep. Sorry, this is not the.
No, please. This is I don't think I'm going to be doing anything after this. Maybe I will. Honestly, we'll see. But
yeah, that'll be up to you. Hopefully you can remake this as something, you know, a lot more polished and just fly
I
through it.
plan on it. Oh well, fly
Yeah,
through it. It's gonna. I mean, there's a lot more details that I need to do,
yeah.
but
But like just a lot of condensed information for people. Like I don't know how many really more advanced layout tutorials there are for Fusion. You know, there's a lot of beginners guides, but
yeah, no, this for
only
like
not
the actual workflow of this is really interesting, and I have a couple questions after we finish this part. I look forward to seeing like
okay.
how powerful this actually is.
Okay,
But
so we'll get through this.
yeah,
Is that sketch? I don't want to sketch. Sorry. Go away. So okay, so I've extruded the outer body. I've got the center pin. I want to
yes,
create. Oh, that's not what I want to hit. I want you to go away. You to go away. I want to hit that and bring this out, and this is going to be my top of my spring. I want this to go to the sides.
yeah, because the sketch is in the dead center, right? So
yeah. So we'll do that and object there and join instead of cut. All right, so I've got that there, and I can hide that. So we've now got the basic pieces, right? This is all fixed in place because it's this one body, and we're going to joint it in a minute once we come back through. I need my hole here as well for this running through, obviously. We can do that afterwards. We'll do it when we cut the spring. Okay. Create another sketch in the mid-plane. So I'm going to project in that top and bottom now. We may as well do this at the top, so I've set the width there. So we have our spring coming down, so that was a line,
now I like doing all just corners in the sketch and then chamfering after after like it's 3D.
Yep. I'm just gonna do it all as
Yeah,
arcs
like what's
because
the no? I like
we
what's the
can.
benefit of making the curve in the sketch? Like,
Oh, because we've got so many, so I'm going to want to set this outer edge here. I want to be
yeah,
vertical with this dot here. So it's I mean you could, I guess.
maybe
Like
it doesn't. If
yeah.
it doesn't matter, then that's all
No,
good too. I'm just
there's multiple ways to do everything in this.
yeah,
So
yeah,
if
yeah,
that
yeah.
suits you better, you know, you can create this as just a square block and fillet it afterwards.
That's yeah,
Um,
that's what I would do. Yeah, okay, okay.
so in this case, I'm going to do it all as one, but we'll see how
No,
we go.
please, yeah. I just want to make sure like me doing it that way isn't bad for some reason. So yeah, but you're gonna make this and then mirror it or not mirror. Oh my god, repeat it. Yeah.
Yeah. And I'll repeat it as a body just because this is going to be too many parts to like it's going to get a bit messy to repeat in a sketch, I think.
All right.
And that way I can sort of set my limits and do some extra stuff as well.
Okay. And so the real one, the thickness is 0.75 millimeters.
One moment, just let me check my kid.
Yep.
Alright, one moment, let me go check my kid.
Okay.
He's being good. He's doing well. He's pretty young, so he's doing well.
That's good to hear. Yeah, Swarm. This is really. He does make it look easy. Well, because he basically knows exactly what he's gonna do. This has been this has and continues to be very helpful. Once he finishes this spring though, excuse me. We should be able to see like the actual power of like sketching everything first and then building the parts based on that sketch, which is not what I was, which is not how I was doing it the first 2 days, or I guess the last 2 days, but it definitely makes sense because like you're able to change the dimensions, and everything will update. Everything will update properly. Yeah, like I would do it that way too, but you definitely shouldn't for many reasons. If you need to change something, it doesn't update properly. So I like this a lot. But we won't be able to see the actual power of it until, well, until this is finished.
Oh, this poor dude. Okay, so we were 0.75 there. Do you remember how much your gap was?
What'd you say?
We were 0.75 on that other
Yes.
dimension. Do you remember how much gap this was?
Oh, the gap. Not that much. Okay. Probably half. Oh, it's less than 0.75.
Oh, okay. Just do 0.75 as well.
Yeah. That's fine.
Do for now.
Actually, okay, hold on. Make it. Let's do 0.8. Just because I think the extruder. I think the print. Oh my god. The printing head thing is 0.4. I think, or is it 0.04? Let's do. Yeah, 0.8. That works.
So just another thing, I can grab that dimension and divide it by 2 to set that.
Oh, that's cool.
Set that width.
The nozzle, that's the word. The nozzle width.
I'm going to do this, and then I can go midpoint onto the arc.
Oh, wow, that's cool.
There we go. So that's the first part of it, right?
Yes.
So you can see if I did this and repeated it down, the sketch is just going to look pretty messy.
Yes.
And then I'm at the mercy of changing things as well. One thing I do need to get is that let's go back. Go on, there. Okay. You can't hear the TV, can you?
No, I cannot.
Cool. Just don't come in. Okay, so we do need to know this height here, as that's going to be our pattern size. So 3.2. I don't think we can reference this for the pattern. Do this. Okay, so I'm going to extrude this, and once again, 2 sides and to the object. And I'm going to choose new body this time. So we've now got 3 bodies. Yeah, 3 bodies. So the inner, the outer, and that.
Perfect.
So I'll now go rectangular pattern with that. Select a line as my axis, and then we're working on spacing. So spacing there. The distance of -3.2 was our spacing between each one, and then we just count up the number until we get past the bottom. So we happen to be the bottom nicely.
Perfectly.
I'll continue it on though, just to show you how I can keep it flexible to changes. So I'm going way past the bottom there, right? So go right there, just in case it's going to be cool. And
so this is rectangular pattern. Did you search that, or is that under modify? It's probably create.
It's create. So create pattern. You've got rectangular, circular, and pattern on path, which you may use once in a year. Okay, so now that I've got this going too far, and you can see all of these bodies it's created. So that's the downside of sort of doing it this way. Actually, maybe I should have done it as.
But you can update the sketch, right? If you update the sketch, okay, yeah, or maybe.
Yeah, that's this as a feature instead, and select that extrusion, spacing, same. No, it's still doing it as bodies. Join. One more, just let me retry that from a new one.
Okay.
Fusion's a bit like this, where we might have to restart it to do it properly. Select that vertical spacing. 2. 9. 2. 3. No. Okay, it's still doing it as separate bodies.
So you
That's
were trying to
okay.
make it so it's not separate bodies.
Yeah. Doing it as a feature, it generally keeps it all together. There's unfortunately no option for, yeah, like when you do it as a body, it definitely keeps it as separate bodies,
Yeah.
but generally when you do it as feature, it keeps it together. I don't know if optimizer or anything will be any more full. No, it'll just run slower. Okay, anyway, so we're patented on that body. I'm going to select them. So I want to make sure I get that. Okay, so combine that and tool bodies as all of these. So that was just selecting the top one, holding shift and selecting the bottom. And
What's the invisible one?
The invisible one is that outside.
Yeah, okay.
Yeah,
Oh, yeah, we're in the tibia still. Yep. Okay.
Technically, seen I'm not going below it, I could actually be jointing that in right now.
Okay.
I actually may as well, since I'm coming down into here. So what I was going to say, I'll do it how I was going to, just to show you, just as a skill. So this is all now one body. I was going to show you, I can create a sketch back on that face. Now that this is definitely too long, I can project in this line here, and just draw a rectangle down below it and cut that excess out, and just keep this in excessive size. So if I now lengthen the length of the spring, I've still got these extra few here. One. I can't. I've jointed it to it. No, there's a dumb way of doing things.
Oh, you can't do that?
Ignore me. No.
Oh, okay.
No, because I'm going to end up cutting this shaft that we've got attached going all the way through.
Ah, okay.
Yep. So I'm going to go back to this combine. I'm going to add that other one into the tool bodies, wherever it's gone. And we'll just combine it all together, and we're good.
Okay.
So if you'd, I probably wanted to do this not creating that shaft yet, and creating the shaft after I do the cut. So I've done this in the wrong order of operations, essentially.
What if you just made the shaft invisible and then cut it?
No, because the shaft is part of the...
Yeah. Now, okay, in real life, the shaft is its own object, right? Like, it attaches into the spring. Does that matter?
Well, this is all one object, because it's attached to the spring and it's attached to that middle piece. It's all one piece.
Yeah, so you're making it in one object. Yeah.
Yeah, but I really should have not created that shaft and done the shaft after the fact.
Okay.
So created this outside, created the top plate, created the spring, cut that spring off, and then jointed all of this together.
Yep.
Then done my cut up.
Through the spring. Yeah, exactly. Yeah, okay.
Done the cut up through the spring, and then redraw the circle coming back down. And I can do that as a reference to the end of my master sketch. So back down to this point.
Right. Okay.
Yeah, so I've just done it around the wrong way. You'll get this a lot as you're figuring things out and going back through and doing things. It just is what you'll deal with. Yeah. You can either type, before you're going to release this for a bunch of people to look at, you might want to come back through and tidy that all up.
Yes.
If this is just for yourself, who cares?
Exactly, yeah. Can you try, so how easy is it to edit the spring now? So let's say I want the gap in the middle of the spring to be half, so 0.4.
One moment.
Okay, yeah.
I'll just finish it off first. And
I thought it was done. All right, yep. Finish it, definitely.
Well, no, because this shaft is currently jointed completely into the spring.
Right, so and you only wanted
to see, but it's all one part, it's rigid at the moment. We need to cut all the way up through that spring.
So you are going to make it move?
No, I'm going to give it the ability to move. I'm not going to actually make it move in CAD.
Got you, okay.
So I'm just freeing it up in reality. I'm not freeing it up in CAD.
Got you.
Fixed, but you've now got how you did having that clearance all the way through.
Yep.
And doing this properly, you'd have a certain clearance for these top and bottom guide holes, and then a different clearance for cutting away from the spring. Mm-hmm. So you'd be doing a second sketch, you do one sketch on here and just grab that circle and just cut down to the bottom of the spring, just so you've got extra clearance in the spring, tighter clearance in here, so you don't have it rattling. Yeah.
Yep, that makes sense.
But that's essentially it. So printed, this will now flex up and down as you had it.
Exactly. Yeah. I mean, we can't print it as is, obviously. Yeah, but it wouldn't print. Well, because the hole in the middle. But I think.
How did you deal with that?
I cut it in half.
Oh.
Could this print?
Quite possibly. I mean, you could do just a little bit of support between the spring and the shaft here, and then have it break away.
Wait, oh, you'd print it vertically?
No, I'd print it, from this axis. So
yeah.
Say we're looking down on the printer now.
Yes.
We need all these lines to be printed with the layer. You can't slice it acrossways like this. It'll just break in the lines. So it has to be sliced like that.
Exactly.
Right?
Yes, that's how I printed it, but cut in half. Because why did I do that? Why did I do that? Because the lower part. Oh, I don't know. Maybe I should try printing it.
Yeah. So
I think there was a reason. There was definitely a reason, but it's okay.
So you could very possibly get away with just doing here, making this say 0. 0.
Oh, and you're saying print the shaft up as a wow? Okay, I printed the shaft part separately, but
I'm saying like all of this print in place.
Oh god.
So you could possibly draw in just a very little gap here. So printing this as thin as your printer will go, and extrude this all the way up. And now you've got just enough support to get that.
And extrude it all the way up. Yeah.
Yeah, and then okay, I've done it as cut, but you get what I mean.
I know exactly what you mean.
It's a hard maybe, but
I don't think that would work. I don't think it would work, but because I think it, I'd have to make more of a tolerance. But
yeah,
that's a hard or maybe a different shape shaft, but that's okay. This is great.
It's absolutely pushing limits at that point, but
yeah.
So you again pushing reliability. So if you're manufacturing those, that would be too much of a push. But at the same time, you want to make something that, something that works.
Right.
Okay. Anyway, we will go back to the master. We're going to extrude.
And then
this.
Do this extrude.
I'm going to project it all in. Where am I sketching? I'm not. Create a sketch there.
So you're going to create a new sketch and then reference the master one.
Yeah, because I'm not using the full size of the thing. I'm just projecting in lines.
Yeah.
Okay. Again, my two objects. I'm really loving. Like, I swear I never use this. Waiting. I swear I never use this two sides this often, but in this case it works a lot. Let's see. Profile. Okay. Distance to. And we'll ignore the rest of what's going on and just call it join.
Yep.
Is that up somehow?
What did you say?
Oh, I've stuffed it up somehow.
Oh.
This. Be that one. Okay. Don't know. Just fusion things.
Yeah.
Body so it actually joins to it. Okay, so there's your basic leg there.
Yep.
Okay, cool. All right, so we now have all of our main parts, right?
And they're all constrained to the master sketches, yeah.
Yeah, so...
all right, so here... Well, okay, first, before we mess around with the master sketches, This I want to see the spring change first. So can you make the gaps of the spring 0.4 instead of 0.8? So like what would that look like? Cuz you go into that sketch and just change that one measurement and then it'll
Yeah, so all of it's being driven off this one measurement, so 0.4.
Oh, but hold on. I still want the thickness to be.
Oh, you want the thickness to stay as 0.8?
Okay, beautiful. Now, does it just magically work, or?
I've done. I need that to be.
Also, yep, that makes sense.
There we go. That's better. So it won't magically work because we've
the distance
changed
is different,
that
right?
spacing.
Yeah.
Yeah. So we have to.
But I mean, that's an easy. You just go back into the Yeah.
So our distance is now 2.4. We just go back into our pattern.
And just change it to 2.4. Yeah.
Distance negative 2.4.
Can you use a formula in that number?
I don't think I can grab it straight from the sketch.
You need the. Oh, you can. Okay.
You can use a formula, yes. So you might be able to create a formula of
a construction line or something, or I guess just take a measurement from
formula.
Yeah.
Well, you'd want the formula to be this distance that we're doing here, and then you'd want that to be your driving factor for the spacing in the sketch. So instead of driving by the space between the two, you'd drive between the total height of it. I'll show you. So, we at 2.4.
Well, I want to drive it by the spacing, but why can't I just like take a measurement that's just like, is it called a driven measurement or?
I don't think you can reference it back into a feature extrude.
You can't.
Or into that pattern. I don't think. You're free to correct me on this.
Yeah.
But,
okay, fair enough.
Spring spacing. So 2.56. So it's a new value, right? So I'll go back into the spring. I'll delete this gap here. Delete that. More things moving. Okay. And then grab between those two.
Yep.
And that was spring spacing. That's failing to solve. Excellent. We are hitting the limits of fusion. For no apparent reason.
That arc doesn't look connected. The top right.
Why is it all break? It is though. See, yeah, we're just breaking fusion now.
We're just breaking fusion.
Yeah, so you watch this here, this line as it comes around. This is tangent, right?
Yeah.
But as I'm dragging it down, it's breaking.
Huh.
It shouldn't be. There's no reason for it to, I don't think. No, 0.8. That.
Is this sketch fully constrained?
Maybe that's why. That's why. Okay.
What?
It was because I had that dimension there. I shouldn't have had that.
Okay.
Okay, so we'll go back to it. Bring spacing. Okay, yeah. So it was because I had that dimension there, which is half of that. So I was partially driving it. I was partially driving it, and fusion was breaking.
Yeah.
So I was trying to over constrain it. So too many dimensions for what it should be. Anyway, so I can now go back into my pattern and
put the parameter in there. That's cool. Okay, that makes sense.
Negative spring spacing.
Look at that.
It is working. It's just different parts. And so yeah, we can now change it by that parameter. So
that's what the real one looks like. That's cool.
So we can do 2.8, 3.8. Don't want to change it too much because we will. If we make too large a change, we will still break stuff. Like it's just fusion.
It'll explode.
Yeah, so we can go 2.8.
Nice. That's so cool. Holy crap. I was manually doing it in Blender, so that was fun. This would have saved so much time. Okay, that's awesome.
Cool. Okay, so we've got that. That's our first one, and now we will. So this is our non-moving master, right? So we've got our master sketches and our master bodies. You know, we want a bunch of these coming around the thing, all jointed up.
And then so you're gonna like assemble. Okay. So how about assemble it, give it 6 legs and stuff, and then I have a couple things I want to see like changed or altered, and that'll alter the assembled one, right?
I'm not going to assemble the full one because
okay, that's fine. Yeah, that's that'll be annoying.
I'll assemble the one leg just
so
you can see it move.
Yep.
So I've saved this now, so I'm going to create a new design, and I have to save it to be able to import anything else.
Right.
So hexapod assembly, save that. Give it fusion time. So I can now, I'm going to be a little bit tidy about this. I'll create a new project that's called body parts. A new component that's called body parts.
Okay.
Just to split this up. So I split it up into body parts, fixings, electronics, things like that, just so I can hide all of them.
What's a fixing? Is that like a screw?
Yeah, screws.
Okay.
Screws, bolts, nuts,
yep.
Your heatsink inserts, things like that. So note that I'm working on this body part now. So when I drag this in, it's going to drag it into here, not into the top level assembly.
Right. Good.
That's important. Okay, so this one will be our body, and I want this to stay still, so you can see everything moves at the moment. So I'm going to hide everything else except the main body, and I am going to right-click on it. My mouse is broken. This is fun. It is literally broken. It's double-clicking.
Oh, no.
And I'm going to hit ground. So ground you have to do on a body.
Yes.
If I used ground on the assembly, it will still be able to move everything within it. Ground has to be done on a body. And I'll do revert position because I just dragged that around off of center before.
Yep.
So this is now fixed in place, right? This is not going to move.
It can't move
this is my
all.
base
part. Perfect.
I'm going to attach everything to it.
Perfect.
Little
pin.
Okay.
Yeah.
And I've just hidden this bit. So still working in that, I've just done Control-C, Control-V, and I can hopefully just hide the body of the second one and show that part there. So we're still working off multiple of our master, but I'm just hiding and showing the bodies that I want and don't want.
Wait, did you import multiple master? Wait, what happened?
So I'll undo just to do it again.
Yeah.
So I've selected this, gone Control-C, Control-C,
you copy and paste? Okay, why?
Yes. So because I now want to do the joint for this part here.
Yeah.
So because all of this is made as... Okay, no, technically you would be able to do it.
Because there are different bodies, right? Yeah.
Yeah, different bodies, so I can joint off of them all. Yes. Yeah, so technically you can do it.
Okay.
So you'd still have to add multiple of them as you add the rest of the legs. But yes, I could just use this one and create joints for it, and then add a second full thing and do the second leg going down, if that makes sense.
I mean, what I would do personally, but when I say that, I just mean what I would try first is just copying and pasting the bodies that I need. Can I even do that?
Unsure. I don't think you can do it separately. So if I try and
if I wanted another Coxa, I would just I would try copy and pasting it, and if that doesn't work, I'd just be annoyed and quit or something. I don't know.
No, you can't. So
you
you
literally
have
just
to paste in a whole
Okay. So one per leg. Yeah. So can you do one per leg, like one hexapod master per leg? That's what I would do.
It really won't be too long. So we'll go to the BMX track. Sorry, the skate park. Yeah, you want to do that? Would you? Yeah, with your bike. Okay, so I won't be too long, Maddie. Give me 10 more minutes, and then we'll go. Okay? Leave that open, please, so Luke can get out. Thank you, Maddie. Oh. Yeah, mate, that's cool. Sorry, God, this kid's been good.
It's okay.
Okay. Alright, so I will now create my joint. So this is why I had that
That little cylinder
Is
thing,
that
yeah.
there? So I want this to be revolute as it goes round and round. I can
Nice.
also do joint limits here, so I can have a min and max angle that I want it to be able to move.
Yeah, 90
So
each side.
like 90 each side. Dang, that's right, servo rotation.
Yep,
Of course.
180. Yep.
Okay, so 90 each side. So that's that. That's now jointed and limited like that.
That's awesome.
So we'll do the same for this. I'm going to do it a little bit dirty because I didn't, you'd be using your servo at this point to
Yes.
do it properly.
Yep.
So I'll this side and grab off here. Chill out, mate. Put it back into
And then you can
place.
just offset it. That's pretty cool.
Yeah.
I
So
won't have to, but
this
yeah.
this is a gross chuck together, but you'll be doing it properly.
Yep.
I hope.
Yes, I will be.
And 90, 90, negative 90, 90, negative 90.
Yes.
Right?
Exactly.
Negative 90, 90. Okay, there we go. Now it's got the full range. Yeah, just making sure that that's correct. Okay, so now we have two parts jointed together, and it's going to be funky because it's fusion. It doesn't move graciously.
Yeah.
Here. No, have I screwed that up? No. Can I grab that and move it? I don't know. It's fusion. It's just going to do fusion things.
Okay.
Yeah.
And
the tibia. So the same thing. We'll grab. I'm just going to grab a point to build off of.
And then the center of the hole. Yeah, perfect.
Yep. And back a bit. And again, minimax 90, negative 90, and 90. So by rights, that can all move now. We have our
nice,
very awkward movement, but that's all of our freedom. So that's cool.
That is insanely cool.
I'll show you one thing as well that will be handy once you're doing the actual assembly.
Okay.
So I'm going to move that so it's inside the other body, right?
Yes.
So say if you've got your servos and everything set up, you've got your switches, and this is just a really good final check to make sure that you haven't screwed up. You can go to inspect and interference. We'll revert position just to chuck it back to where it was and hit compute. No interference detected, which is a jolly lie.
Yeah, is that... Yeah, wait a second.
I wonder if I had to do it as separate... One moment, I'll do it as separate things. So maybe we do have to do it as separate parts for that to work. I'll get rid of that and make it new one. Position.
As separate, like, assemblies?
Maybe just separate parts, like separate assemblies. So maybe it sees all of the parts in this are the same part.
And it wouldn't check the interference, yeah.
Yeah, so we'll see if we do it this way, if it checks the interference. But yeah, interference is a really good way to save yourself on screw-ups.
Yep,
So when you've got a servo that's clipping into a part, or you haven't allowed enough room for a switch or something like that, it's a great way to just be able to catch yourself out.
Yeah, before printing everything, and
Yeah, just as a final check, once you've done this full assembly. Okay, I don't know why that's not working.
No, don't worry. No, that's fine though.
It's true. Anyway, it is something that is worth checking. I'll show you it on the scanner just for, so you not that one. Dang it. Whatever. So I can do it in this one and do interference. Okay, no, it's just broken.
Okay.
Oh, right. No. Sorry. I'm doing it wrong.
Do you remember?
Don't...
Okay.
Yeah.
Do you have to select everything or something? I don't know.
You have to select everything. I'm just being a nonce. Sorry. So select the top assembly. Compute. There we go. It's got our interferences. It shows them in colors so you can see them all around.
That's cool. And can you delete that one and just do it for the one assembly?
Yeah, so I assume that would have... Yeah, it's doing it as the one assembly, so you didn't need to create that second assembly for it. Yeah, it was just me being a nunce.
No worries.
So yeah, that's sort of it. Is that cool? So
this is awesome. Yeah. So okay. I can you demo the power really quick? I promise. Can you demo the power of just like making the master sketches. Can you make the
Okay.
femur? So right now, if you move the femur, if you rotate it up, you'll see that it probably clips with the coxa, right?
So are you talking in here?
Well, yeah. Like if you rotate a little bit, you'll see the gap in the femur isn't big enough for the coxa, right?
Right. So you
The other gap,
you are mean.
lower gap. Yeah, that see.
Oh, down here.
Yeah.
Down
Okay.
here. Right.
So
Okay.
and I'm like,
Yep.
that's not good. Can I?
Okay.
I want to make the femur, that part of it, longer, right?
Yep. So
So
you come back
see
into
that,
your
and it'll
master.
update everything. Yeah. Let's see that, and
Yep.
then I'll let you go.
Okay, cool. So I think femur side was where we set that dimension. So we can date that to 150. Go OK. Everything will update down the line.
That's awesome.
We save that
Yeah,
and jump back into our assembly. Hit update. 1 moment, matey. Like literally 1 moment. You're doing really well. And everything's updated.
That's
it's just showing
dude.
that master sketch because I showed it before. Yeah. So now that's updated. So you can, and that'll update on all of the legs at the same time and everything else at the same time.
That is wonderful. Oh my God.
While still maintaining your joints and everything. So yeah, that's the point of it. That's why we've done it, is so you now have that ability.
Yeah.
You know, you could have done it in the part, but it's just for the other. You now have one place to go. You know where to go to set it instead of digging through each part and trying to figure out what you're doing. So yeah.
That's awesome. Hey, thank you so much, man. I really appreciate it. Can you send me this file? Not for me, just to link in the video for anyone curious. I promise I will not use this.
Sure.
Thanks.
Yep. I'll flick it through the
Discord. Yeah, perfect. Is there anything you want to plug for you, like, or at all?
Okay, so I've got 2 requests, if that's cool.
Yeah.
So I like hexapods, right? But when I see people make 4-axis ones, they always do another axis down here, right?
Okay.
And I feel like that doesn't actually give you much more ability to do anything.
Agreed.
But if you do, just sitting still, matey. No, just staying still. But if you do 3-axis, calling this the shoulder, right?
Mm-hmm.
If you do 3-axis in the shoulder and then still just your 1-axis out here, you now have the ability for your front legs to rotate up and grip things, right? So you can now actually use them as manipulators.
Oh, that would be sick.
So I'd really love to see a hexapod like that. So once you're finished with this, if you're up for building a second version with more complexity, and you're doing your own IK, that would be awesome.
Oh God, I was gonna just slap an arm on top and call it a day, but no, I love the idea of making the legs as arms as well.
I'd love to see it walk as well, because as you've got a sort of a 2D gait currently.
Yes.
But you'd have it walking and you'd have this arm rotating as you go from front to rear. Like you'd be reaching out, rotating, and then rotating all the way back. It'd be more akin, I guess, more as an ant. Oh, I actually don't know if an ant or a spider do.
But yeah, you just have. I don't know. It's super flexible. That's cool.
It would just be interesting to see. So if you feel like it, that would be cool. The other thing, I showed you the 3D scanner. If you want to plug a bloody dead YouTube channel, like I haven't posted anything there yet.
That's okay. Yeah, I'll link it.
Yeah, but this has been oh god, it's a long project. I've been at this for like 2 years now.
Cameras in it or something? Like, is that what you said?
Yeah. So this is a DIY 3D scanner. So a 3D printable 3D scanner is the goal.
3D printable 3D. That's really neat.
So I've made all the files for it, and I'm working on all the software for it. And the goal is for it to just be a low-cost subscription, like just a small monthly fee subscription for the software, and then open source hardware for it. And yeah, the goal is just making it something that's real foolproof, like fun build for tinkerers. You'll need a little bit of soldering and 3D printing in there, but it's sort of a good weekend project to put together, and then I'm working on making everything else really easy to use.
So you point it at something, it films it, right, and it converts it into a 3D file.
Yeah, this works with laser lines. So you just move it up and down over the surface, and it gathers those points and gathers the surface.
That is seriously really cool. Does that exist like cheaply?
It like there are cheaper scanners now. I started this 2 years ago before the cheapy scanners started coming out, which is great. So you've now got other options, and they're not bad. I'm still undercutting it with this, but my goal is to have better software than what you have to deal with those other scanners.
Nice.
Because you're generally dealing with Chinesium software,
right?
Which isn't the most intuitive. But yeah, I'll link you a dead YouTube channel, and then eventually, as I start actually posting, I'll be posting updates to that for anyone that's interested.
That's
so
awesome.
That'll be cool. So that'll be Mataray as the
Matterray.
YouTube channel.
Sick.
Yeah, finding a blimmin.com name is real difficult.
Yeah.
Cool. But yeah, that's been a large project. So you can see I'm
Dude,
at
I can't even
revision
imagine.
9 in CAD, revision 3 printing it.
So that was 12/16. Is that 4 months ago ish? When you started?
Yeah. So. Yeah, that's layout 3, so I've...
Oh, 9. I see a 910. I see it. 910 2022.
No, I've brought this across from another Fusion
my goodness.
account, so it started before this.
That's awesome. But
wow. Yeah, it's a long project, but...
you said 2 years. Yeah, okay.
Yeah, you end up with... like, I'm at least proud of how this frame sketch has ended up, having it nice and tidy with all of
it looks tight. It looks clean. That's awesome.
Yeah, and
looks like
it was a bit of learning.
I'm not sure if that's intentional.
It very much is a phone. Yeah. It started as a very older looking phone, like it was not pretty in any way, so I've at least made it slightly modern while maintaining like fully printable.
That's awesome. That is awesome.
So if I hide it, everything's 45 degrees coming up. I've got where are we? Where am I? Bodies. I've just made up custom supports for it. So custom supports for just everything, just so you can break it away really easily.
Yeah. Have you 3D printed this?
Yeah. So I'm up to version 3 that I've 3D printed, but I haven't 3D printed it with custom supports. I've had to break them away. My printer sucks. Yeah. So breakaway supports have not been fun at all.
Yeah.
But yeah, it's a project. Hopefully it will get there one day. So we'll chuck the link in and appreciate that.
Yeah, of course. Yeah, of course. That's awesome.
Yeah. Cool. So yeah, it'll be cool to watch you. So hopefully continue to make progress with the thing, and we can keep on seeing it evolve.
We'll see, dude. I hope I can make you proud. Well, I'll probably be streaming this tomorrow. Thank you again for this. I really appreciate it, and hopefully it'll help someone else. Tidy up the
hopefully you can sort of take this and condense it down into half an hour to an hour of just real dense running through things, and without the talking and without the running through, without the actual designing, and make that into a just a dense tutorial video.
No promises on on that.
Hey,
but I will have the VOD public, and I'll give it a nice thumbnail and description and like all the SEO stuff. And
no, that's cool. I mean, you're doing well video wise so far, so
thanks,
just keep at what you're doing. Did anyone else in chat have any questions?
We did have we had one request. It wouldn't be that difficult, but I know you have to go. Do not feel bad if you can't do this. Just how to make a gear, but
a gear. So I don't make a gear. I go into utilities. There's add-ins. And you go and find an add-in that makes a gear.
I love it. That's great.
You don't make a gear from scratch. You find someone that's made a script that does it for you.
There you go. That's good advice. So that's not what I would do.
That'll just give you the base body, with all of the rotations in it, so it meshes nicely. Yeah. And that's just the base body. You cut it from there and do what you need with it.
I didn't even know add-ins was it. Yeah. Okay. Utilities add-ins.
Yeah, so that'll take you to the Fusion site somewhere. There's some Fusion 360 App Store, so you can go there and just browse for stuff. It's not huge, but there's stuff there. Another thing you might want is you can do insert, and you can insert McMaster car components. So screws and stuff like that. Yep. You can just grab off of the website and have a detailed 3D model of things and whatever they have, which is pretty nice.
That's awesome. Yeah, makes sense.
But yeah, there's more to it. You'll have fun with it. You'll learn the limits of Fusion and start breaking it. It's got its limits.
Yeah,
but yeah,
I'm always assuming it's my fault, but maybe I'll get to the point where it's Fusion's fault. We'll see.
Oh, you'll find out when it is.
Okay.
Cool.
All right,
Thank
man.
you guys.
Yeah,
Cool.
thanks for doing this. I appreciate it.
That is all good.
Yeah, have a great rest of your day with your kid. Skate park?
Yeah, we'll go. Yeah, to the skate park,
Hell
mate.
yeah.
We'll go try and burn some exercise. Poor dude's been sitting in front of the TV. That's not great.
Yeah. Relatable. That is very relatable.
Cool. I'll let you end it just so it goes in the right order.
Yep. All right. Thanks for this. Yep, I will end the stream